Okay. Check one, two. Check one, two. Testing, testing. Let me know in the live chat how everything sounds. And let me know how everything looks. If the picture's good, if the sound is too loud, maybe a bit. Maybe I'll turn it down a little bit. Gotta just grab some water really quick. Because it's probably going to be quite a stream. What's up, Annie? Please, if you have any questions during the stream, comment them in the live chat and I will try to get to them. If you're watching this not live, comment them in the comment section and I will try and get to them. We're going to start doing live streams that are specifically for questions only, like last week, at least probably once a month. And in those, if I don't get to a comment, I won't get to comments from previous videos on this stream, but I will go over comments and try and answer them in those streams. And so if you have any questions, please comment them down below as well for a future video. I think this should be a pretty epic stream. This is one I've been excited for a while. This is Eric Weinstein's most recent discussion on Curt Jaimungal's Theories of Everything YouTube channel, which I highly recommend subscribing to. Curt has great content. If you are familiar with this channel, then you're very familiar with Curt's channel, and you're probably fairly familiar with some of Eric's work. But geometric unity has been something that most have failed to communicate well, and are only starting to now seem to be able to communicate well. And big part of that was Curt. Curt put up a 3.5 hour long deep dive into GU. And I know that after this, him and Eric are probably going to have another more in-depth talk. This one was apparently pretty last minute, but it was very good. And I wanted to give some of my thoughts on it because I think that it's a very important conversation. Even if we don't dive too deep into the equations, which I'm not a mathematician, so I'm not necessarily the best person to do that, but Curt dives into them very deeply in the full video of this and in his geometric unity deep dive. And you can find the full discussion that we're going to be commenting on tonight linked below. Please hit the like button. It really helps fuel the algorithm and helps boost this content. I will say, for my universal disclaimer, I don't agree with anyone on everything, but I agree with everyone on something. And especially here, when I'm trying to kind of understand someone's ideas that aren't spoken in exactly the same language that I'm used to, which in this case is mathematics. If I ever misinterpret anything, anyone whose idea I've misinterpreted on these streams, definitely let me know. And anyone whose work I talk about on here is always welcome on here. So with that said, this is the talk that we're going to be referencing. It is Geometric Unity, 40 Years in the Making. With Eric Weinstein. And they talk about a lot on here. I will say I know Curt just put up another stream that I started listening to the other day, and that's another one that I think we'll probably do a stream on. But with Elon on AI, I would definitely recommend watching that one too. But we'll talk more about that one another time. But my recent live stream, not last week, but I think the week prior, we talked about Eric Weinstein's appearance on Piers Morgan with Sean Carroll. And I try not to focus on, the same person for consecutive weeks in a row, but sometimes when there's something going on, some conversation, you gotta, focus on it because it's just important. But this discussion that he had on Piers Morgan with Sean Carroll was definitely very important, I think, for the physics debate. And I put up my own commentary on it. And last week, I shared a funny video that Eric had posted on his Instagram, which I highly recommend watching as well. It's in the beginning of last week's video, where he's basically just showing that the establishment is lost or failing. I don't even want to say necessarily how intentional or unintentional these things are. I think it's both, like I said last week, the misunderstandings that are being kind of promoted by academia are both intentional and unintentional. But that clip shows just the serious gap in and failures in modern in the modern physics narrative among academic physics departments to basically truly entertain any new ideas. And when I say truly entertain any new ideas, I mean you have to and they talk about this on here, which I think is very important. We're going to talk about it a bit. Is you have to assume that that an idea that you are skeptical of is true, and then look for evidence that it's true. You can't just look for evidence that it's false. That's not actually thinking about anything. You're just kind of reinforcing your confirmation bias, and it's not the same thing as steel manning. You'll always misrepresent the idea, the other person's ideas, even within your own mind, to yourself. And so, in order to keep your mind honest, and I don't just mean honest in a way of like, oh, you're in a deceptive kind of way, but kind of in a true type of way of understanding the honest perspective to look at something, or the right way of looking at something to in a steel man type of manner. Not what your interpretation is, but what they are saying their interpretation is of an idea. You have to assume their idea is true and then understand it enough to kind of understand what would be evidence of it and look for evidence. And I think Eric's theory, I will just state, and I've stated on here many times, I think that geometric unity is a very important theory for physics. I'm not going to comment on how true it is, but I will say that I definitely see a lot of structures in my metaphysics work that seem to align with a lot of quantities and symmetries that are being described or seem to be described in geometric unity. I'm not a mathematician, so again, if I misunderstand anything here, any of Eric's theory is, I'm not trying to misrepresent any idea, but we're going to try and show some of the reasons why I think a lot of what geometric unity seems to be describing may be true. And I'm a philosopher. I'm not a physicist. I'm not a mathematician. So this is my best effort. But regardless, it's a great stream. Their full discussion, again, link below, but we're going to get to their first clip. Here you go. This is about what is the core, ideas in geometric unity.
What is a core idea of geometric unity that if people knew more about it would get them as excited about GU as you are?
That despite the fact, it's a great question, first of all. I believe it is the only claim of a theory that starts from essentially as close to nothing as you can in mathematics to try to derive everything we see. And because we see a world that is complex and baroque, like the standard model in general relativity, that process of development and unfolding has to be fairly lengthy, just the way human development from a single fertilized egg is. And I think that what gets lost, and I think what you did beautifully, is to show that just because something has a simple starting point doesn't mean that the theory remains simple. This concept of writing something down on a napkin that represents the entire world skips many steps if what you're really trying to do is to understand where you are, who you are. And I think the fact that it starts basically from 4 degrees of freedom and a tiny amount of sectoral information, like which spin structure is active and how many temporal dimensions do you want, that's it. That's really the only starting point for geometric unity. And the only comparable claims that I know of would be Garrett Lisi saying, let's start from the most complicated, simple Lie group possible. Peter Voigt saying, let's start from SU4 and we'll quotient out by SU3 cross U1 to get the electrostrong group, and then we'll try to figure out how to get an SU2 from a Wick rotation inside of a projective space. Or Stephen Wolfram saying, maybe this all comes out of a very simple cellular rule. And I don't think that any of those have actually gotten to the point where they can make the claim that that's a logical train of development. So to me, that would be one way of answering the question. Another way of answering it is, how much do you care about the actual particles of matter that make up everything? Like, do you care about the up quark, down quark, electron, tau particle? you care about these symmetries of nature? Where is this crazy SU3 cross SU2 cross U1 coming from? Why are the three generations? Why is this chiral and therefore asymmetric? Left-handed, right-handed are different. And I guess one of the things I'm astounded by is the way that those questions, when I was 17, were on the lips of every theoretical physicist. And through whatever process we went through, starting in 83, 84, those questions got relegated to not particularly interesting or relevant questions, which I think, if you told me that you could get physicists to stop worrying about three generations, the famous who ordered that problem in Isidore Rabi, I wouldn't have believed you.
So 2 notes.
Okay, a lot to unpack here, but I actually agree with this. I think I understand why he's referencing the other two, Garrett Lisi with his theory of E8, kind of representing, the structure of the universe in a fundamental way. And then I think that that's onto something. I do also think that, turn this down a bit. Let me know if it's too loud, by the way. I also think that it makes sense to try and start with, a simple cellular rule and see if we can build from there. That makes a lot of sense to me. And I don't really understand Peter White's theory that much, but I mean, it seems to start with, SU4. Eric's theory starts with basically like, let us assume that 4 degrees of freedom, or 4 dimensions, essentially, and that's where it starts from. This, again, I'm going to try and relate why I think that geometric unity, according to my metaphysics and philosophy work, how my metaphysics and philosophy work with sentient singularity theory seems to support that geometric unity might be probably the best, or one of the better directions for us to go down when it comes to exploring new theories in physics. And but again, sentient singularity theory is a philosophical theory, and which is it's a metaphysics theory of mind, essentially, and how the mind organizes information and processes information, and how that is relevant to metaphysics. And then I think that is a critical component of adding context to our physics again. We don't have context in our physics, and I think that we need to. And this is kind of what the point is of sentient singularity theory, or at least like what is the relevance of sentient singularity theory when it comes to physics. And then but it's not I'm not as concerned with, maneuvering time spaces or I don't know, over sidestepping the constraints of relativity as GU might be. And I think that a goal is quite an important thing when it comes to these theories. And a lot of them have become quite goalless, and they also are not focused on the same things as geometric unity. And this is another reason why I think that GU is honestly one of the better avenues to go down. Is Eric seems to be focused on explaining why we see certain structures in physics that we see, like the symmetry structures in the Standard Model and certain, I'm sure, phenomenon in that appear in general relativity. And that's not the concern of our current leading physics theories, which is like string theory, where they're trying to explain to you. I don't even know if they're trying to explain to you. They're telling people that there's 11 dimensions, and that instead of 4, and that there might be a multiverse, or there might, and they're looking at many worlds. And I don't just mean many worlds in the quantum mechanics interpretation, which I still think is just probably not great, but I mean also in the cosmological interpretation, which I also think is not great. And none of these things nobody was asking these questions until, I think, and I don't know for sure, but until a lot of structures started to come out of string theory and mathematics that are not able to be, as of yet, mapped to our physical world. So in order to do this, they expanded things out and started saying, maybe there's 11 dimensions to space, or space-time instead of 4. And this is not useful because we don't even have explanations in physics yet, or in philosophy yet, or metaphysics or whatever, for what we currently see in physics, which would be like, why do we see 3 generations of matter? Why do we see the symmetry structures in the standard model that we see? Why do we see, time seems to move, or time seems to pass or move in a relativistic manner depending on, mass, and like all of these observables within general relativity and all of these symmetries within this, the standard model. Why do we see these things? This is the theory. These are the theories that we need. And I think that Eric's focus on this is a point. And I don't know why. It's an actual physics theory. These other theories, where we're mapping these abstract manifold structures like a Calabi-Yau manifold or Bott periodicity, and we'll talk about both of those things later. But or I know that's not string theory, Bott periodicity, but it's just an abstract mathematical structure of, loop spaces, essentially, from what I understand. And we don't have, there's no effort right now to try and map these things onto our physical world that is proving to be successful. Yet we're still told things like a Calabi-Yau manifold is 6-dimensional manifold at every point in space and time. And nobody can explain what that is. We need theories that start to explain what that is. And that's going to be a philosophical theory. It's going to be a metaphysics theory, which is a philosophy theory. And that's what Sentient Singularity Theory's attempt is, which is it's about the processing and organization of information by sentience. And then you are going to any physics theories that we have, any new physics theories, would be theories that make predictions about abilities to take advantage of new degrees of freedom. And we don't really have any theories in the mainstream of physics that really seem to do this. And according to Eric, his theory seems to do that. And it does kind of make sense that I'm not a physicist, I'm not a mathematician, but the structures that I see in my metaphysics work seem to produce some similar quantities and symmetries that seem to be described in GU. So I think that it would probably make sense that that might be a good physics theory to look at if you are looking for additional degrees of freedom. And so, that's a huge thing. It's like, is your theory trying to explain our current physics much more so than string theory? And I understand that string theory was an attempt to do certain things, but there's a lot of things that are not even being asked by physicists these days that Eric called out perfectly, and that there's no explanation for. And I talked about this last week or the week before, where science has really confused what an explanation is. They've confused description with explanation very, very often. And so they'll say, well, why do we don't need anything else? We see, we have the quarks mapped, and we've got the 3 generations, and we've got the neutrinos, and we've got, the electron and the muon and the tau. And it's like, but so we've got it, we've got the standard model, but we don't have an explanation for the standard model. And if you want to understand how to unify different structures in reality, whether that's, up a chain of construction from, physics to chemistry to biology to even sociology, or you're going to be within one field and you're going to look at physics and you're going to look at quantum mechanics and you're going to look at general relativity, and you're going to try and figure out a way to unify these things or relate them to each other in a way that kind of they help explain each other and give context to each other, you need to add more context, which means you need to explain what we currently see, especially if you're going to propose what you're going to call a more fundamental theory. And ultimately, I think all physics theories are going to be contextualized by a philosophical theory or a metaphysics theory, essentially. And Eric states this as well, as that going beyond 4 degrees of freedom is going to be kind of the job of philosophers and theologians, which I appreciate him saying that. But what is physics? What is metaphysics? It's gonna start to get kind of blurred, I feel like, and I don't really have the answer as to what is the dividing line there. I think it's more about, I guess, maneuvering in the physical world. And so, if your theory is claiming to possibly enable new degrees of freedom in order to maneuver in the physical world, I think that your theory should be focused on much more so than a theory that may eventually end up leading to taking advantage of new degrees of freedom of maneuvering and the manipulation of matter in the physical world. But that should not be that. You should prioritize the theory that's already seeming to include a claim to increase that ability, because that's a physics theory will be testable physically, and any new physics theory should, if it's true, lead to new physical abilities. I'm not even saying that we should take advantage of all of those physical abilities. Should we, you can be making nuclear power, or you can be making nukes. Maybe you can overcome distance as a constraint when you're sending information in a more fundamental theory. I don't know. Or sending yourself, even, I think Eric's Twitter says, assume a traversable cosmos. And he believes that geometric unity could help us overcome the constraint of distance, essentially, and leave the solar system. I'm not saying it can't. I think it probably actually can. I don't think it's as necessary as he thinks it is, but I do think that I understand why he thinks it is. And, I do think it's very possible that GU may be the theory that allows you to do that, even if it is not as necessary as he seems to think. Who knows? But next clip. This is something that I thought a clip that I think is very interesting, and it's just something that I remember saying many years ago and just being kind of dismissed. But we will watch this first and then discuss it.
Like the bundle is probably the right concept. Like the bundle is probably the right concept of the ether, And instead, for some reason, they stopped minting new words after ether. So we're still discussing the ether, and we're not discussing bundles. So if you're a wave in a medium, the universe is a newspaper story. You want to know where and when, who and what, how and why. Where is space? When is time? Put the two of them together, you have space-time. Then there's the who.
By the way, that where, when, who, what, where, when, and why, it's probably a Ekkolapto manifold.
What? Those are the bosons and fermions that make up the matter in the case of the fermions, and the force and the other fields in the case of the bosons. So you have matter acting on force and force redirecting matter, whichever way they're interacting. And then how and why is what we would call the equations in the Lagrangian. And so that's a pretty good idea about how to remember how a physicist thinks about reality at the deepest level. Tell me where it's going on. Tell me what the equipment and the players are. And tell me what the rules are and what the consequences are. So basically, geometric unity says that we have this wrong. Not wildly wrong in the sense of I can't connect it. It's very connected to what I'm claiming and what Einstein was claiming, or what the authors of the standard model are claiming. But the first thing is that the arena is not space-time. It's a different kind of a gadget called a bundle. And one thing you can think about it is that there's sort of two spaces in a bundle, not one space. And that gives you a little bit of an opportunity to say, maybe if you're going to sacrifice accuracy, let's go for it. The quantum is happening on a 14 manifold, and the classical is happening on a 4 manifold, and they're not on the same space. They're not native to the same space. So a lot of the attempt to say that you have to quantize gravity, or which slit does the photon or electron go through in the double slit experiment, all these things come from the fact you're trying to answer a non-space-time question in a construct called space-time that, because Einstein sort of wrote down the rules around 1913 through 1917, sometimes with Grossman, sometimes in rivalry with Hilbert, that story has confused us. It's like having a Mercator projection of the world on your wall and starting to think, well, that is the world. No, it's a distortion. Einstein distorted the world for his time, and geometric unity asserts that ultimately, if you want to not look at the map and you want to look at the territory, you have to keep putting in a new map until finally, in the end, reality is its own exegesis. There's no tool to look at it. So geometric unity says you're not living on one space, you're living on a relationship between two spaces. And in that relationship, you've put the quantum on one space, the classical on another, which decreases the amount of conflict between them. It also says, for example, that the classical world is by far the more important of the two worlds than the quantum.
How does it say that?
Okay, we'll continue with that in a minute. But so again, disclaimer. Just because this is, this language that Eric uses is not the same as what I am familiar with all the time. So, but some of it is, makes sense enough. A bundle, but here I will say that I never understood why people said that the ether doesn't exist. And there was actually a mutual friend of Eric and I think, got into a discussion about this years ago. It was me and Brian Keating, and we were talking about this. And he had said that there was some experiment or something like that. I need to look up the details. I forgot. It's been many years. That proved that the ether doesn't exist. And I'm sitting there thinking, like, what even is the ether? The ether is just like, it means like a fluid, essentially, or at least like the perception of a fluid. Which really just means like a moving medium. And so I don't understand how you can just say the ether has been disproven when, I'm not saying that this proves the ether. I'm just saying, think about our physical world and how we maneuver in it already with planes and rockets and submarines and boats. It's like everything is moving in a fluid. All of our ways of maneuvering are maneuvering in a fluid when we're thinking in within the realm of general relativity. So like, why would you even think that? Why, I don't understand what he's considering the ether so specifically that we were able to disprove it without even defining it. And I'm not saying that the ether exists or doesn't exist. I don't know what Brian meant by that. But I think that it's a philosophical concept, the ether. It's not a physics idea that is just itself, so quantifiable and so defined that you can just say it does or doesn't exist. I think that you have to define what you mean by ether before you start saying that it doesn't exist. And so it's funny now, though, because if you use that term, you're labeled like a woo-woo person or something like that at this point. And I'm not, again, I don't think that it's the greatest term to use, because it, at least in the context in which I work in, you're trying to overcome relativity. And if you do try and overcome relativity, but you're still in a space of multiplicity, in a relationship space, which is what the sentient singularity theory is mapping, essentially, then it is kind of a bundle space, which is just a space of change. And, that's why there's like this thing. We talk about this on how we can ask this 4 questions about the structure of this right here. We can say, where do you see the square? Yes. Do you see the squares? So singularity versus multiplicity. The square, yes. Do you see the squares? Yes. Do you see the wave? Yes. And you can also finally say, do you see the helix? And the universe it's not just this. It is a structure that is moving constantly. It's an animated structure. Okay. And you are proof of this. You yourself are proof of this. And everything that you see around you and all the change that we have observed throughout our lives in ourselves and outside of ourselves is proof of this. So it is a dynamic structure. And so that means that the questions that you ask will dictate the structures that you see. Okay? Just like I demonstrated. So this is why it's important to have a goal in the questions that we're asking about dimensions and degrees of freedom and what, kind of analogies or metaphorical labels like the ether or descriptive labels like the ether. You need to ask the right question or have the right context in order to see the right structure. And this is what is missing from physics entirely. I'm pretty sure Eric describes himself as an atheist in most podcasts, but I don't know exactly what he means by that, because he uses some terms and that just imply a more, I guess, animated assumption about some structures in the universe. It seems like when you say relationship space, when you say it's a relationship space, you have to say what that means. And I will say what the context is for sentient singularity theory for a relationship space where two overlapping four-dimensional structures seem to create like a 14-dimensional structure. But I don't want to say that is exactly what Eric is that's not that same as not going to. I don't want to say that's how that's the context that Eric is giving to his work, because he describes himself as an atheist, and I would definitely describe myself as a theist. And sentient singularity theory is a theistic theory. It is a theory that places a single sentient being as an inevitable structure and gives an example as to why, and then kind of tries to map the nested structure that it is creating within itself of nested sentient beings, and tries to map this structure that is beyond relativity. And so getting to that, where I will try, and with all that said, I will say, I will show now many overlapping quantities between geometric unity and sentient singularity theory throughout this episode. And again, I don't know if the structures that I see are the same structures as geometric unity, but what I will claim, because I'm standing by my work at least, and I also think that Eric's work seems to suggest a lot of correct concepts, I think. I would say that certain explanations that I give may be responsible for some of the structures that Eric is seeing, even if they're not the same structure. So if I show a 14-dimensional space, or attempt to show where maybe a 14-dimensional space may come from, I'm trying not to say this is the Observerse, because that's not my idea. I do like the term though. But the quantities seem to make sense, and the descriptions that he's giving seem to make sense, where he's saying it's two spaces and it's like there's a relationship between these two going on. Sentient singularity theory would propose that there are two sentient beings in any perspective that you're perceiving from within the universe, because you're a cell inside of a body. Okay? That's what you are in sentient singularity theory. And so there's four primary perspectives that are perceived by every sentient being in sentient singularity theory. This was the beginning of sentient singularity theory. It's these four dimensions, essentially, and I call them the four primary perspectives, which are like degrees of freedom of perception, essentially, and they are simultaneously generated. So you go from one sentient being that perceives four primary perspectives simultaneously, and these are these perspectives that I think are responsible for when Eric says we start with a four-dimensional manifold, and he doesn't have an explanation for that. I'm going to give my proposal for an explanation for this, which is these. They are inside, outside, separate, and oneness. And they are simultaneously cogenerative, and they allow for the perception of relationship structures beyond a relativistic context. So, or primary to a relativistic context. So when I say relativistic context, I mean bigger than, faster than, stronger than, anything that's spectrum based. And the reason why they are simultaneously cogenerative is if you were to say something is inside of something else, that means that you must intrinsically understand what it means to be outside as well, because you must understand what it means to be outside in order to understand what it means to be inside, and vice versa. And you also need to understand what the kind of perception of oneness means and the perception of separateness. So if something is inside of something else, it's separate from it to some degree, something else or someone else. And these, again, are just like inside and outside. They are simultaneously understood perspectives. And so, in fact, all four of them are, and they are co-defining. So in a nested structure, that is the structure of Sentient Singularity Theory, which is about a sentience that is creating additional singularities of sentience within itself, which just means a sentient being. But a sentient being is someone, which is why it's singular. It's singularity. I'm not stealing that word from physics. That word existed prior to physics. In this context, inside means separate and oneness. So they're co-defining of each other. Because think about, a fetus inside of a mother. Is it a separate body, or is it, the same body? We ask this question endlessly in politics. Sentient Singularity Theory's four primary perspectives seems to suggest it's both. It's separate and one, which is why you can't ever answer the question, because the answer is C, all of the above, not A or B. And outside is separate from oneness. Again, instead of separate and oneness, it's separate from oneness. Oneness is outside and inside of separateness, and separate is inside or outside of oneness. And so they're all simultaneously co-defining and, co-perceived, I guess, by one being. One being perceives four primary perspectives in Sentient Singularity Theory. This is why you will see, I believe, four dimensions at the most fundamental levels of perception. Four chord songs even being perceived as a completion. It's like 1, 2, 3, 4, or even stability in physical space, with even a table that has four legs and a chair that has four legs, or a car that has four wheels. It's just the point in which stability is perceived by an information processing structure because of this. Because these four primary perspectives are simultaneously understood and perceived as soon as anything is understood and perceived. And so it makes sense to me. This is my reasoning why I'm saying it makes sense that a physics theory would start with 4 degrees of freedom, because every sentient being will perceive 4 primary perspectives. And if you're a sentient being inside of a sentient being, then you have 2 4-dimensional structures that are overlapping in their perspectives, okay? The mind that you're within and the mind that you are, okay? And so when this occurs, you get this in my work. And so we're going to talk about this more as time goes on of this channel, of the stream. And I'm stumbling over my words a bit because I'm trying not to gaslight anyone at this, in this. And so I don't want to say that what this is the Observerse. But what I am going to claim is that this is probably why the Observerse is perceived, at least. Maybe it is also the Observerse straight up. I don't know. But if Eric would have to state, okay, yeah, like this is, a mind within a mind. And I'm not going to claim that that's his claim. He'd have to give that context. But that is the context of sentient singularity theory. And I am just, trying to show geometric unity, even if Eric describes himself as an atheist, it seems to line up with a lot of the structures that I see. And so, yeah. Let me know if you have any questions in the chat. I'm trying to be very impeccable here with my words, because I don't want to make an assumption that what I am seeing is exactly what he's describing and is his understanding of it. I don't know if that's the case. But I'm just saying this is what I see, and it seems to line up. But when we're talking about physics and we say, well, there's 4 dimensions in physics. There's, length, width, height, and time in space-time, 4 dimensions to space-time. I'm saying those 4 primary perspectives are why we perceive that. That's what I'm saying. And any other 4-dimensional structure that has fundamentality to it or completion to it, even weird things like 4 wheels on a car or a 4-chord song. It's how your mind is processing information. And so this is why sentient singularity theory is inevitably relevant, or at least the context or the goals of sentient singularity theory is inevitably relevant to any and all physics theories. In fact, all theories, because the context, and I said this in my Theories of Everything, the how-to guide video, which is linked below as well, which was my entry into the PACE 1 contest that Curt Jaimungal put out there, and was, I didn't win first place, but I guess you could say second place. It's like one of the prize-winning videos. Not trying to sound arrogant, but it was good, and is my point. It's worth watching. The reason why I bring it up is that we need context to physics, and I think that it's the job of a philosopher, as Eric has stated, and theologian, or a theistic philosopher, to try and provide context to physics theories. That is what I'm doing. This is kind of tough when you're speaking about someone's ideas and they're using terms or they're speaking in a language that is not so obviously relatable. If we're talking about Bernardo Kastrup's analytic idealism, it's much easier. But if we're talking about geometric unity and they're talking about bundle structures, this is a bit more, there's an added degree of removal or there, because, or a step between that, because we have to say, well, this is what is responsible for the observation of these bundle structures, because the mind itself is a bundle structure. And so that's what I'm proposing. And it is a knot of information that is self-referential and is organized in a way that differentiates that information and organizes it into a hierarchy that allows for differentiation and the perception of an understanding of causation and the perception of generationality, as we will get to later. So it's tough, but I don't think that physics, even now, in the mainstream, is even capable of doing this. And I think that it's important and interesting that you always need to get to these descriptions that seem to be a little sentient-y in how they are in the language that they're using to describe them, like saying it's a relationship space, or it's a space of relationships. It's like it's 2 spaces. What does that mean, 2 spaces? I'm saying it's 2, like space is your perception of space. That's of of additional information that is beyond you. And so what is the space in which space is perceived is within the mind. So I'm saying there's two minds overlapping, and these, I think, are what, at least the reason for the perception of the structures that Eric is describing when he says it's a relationship between two spaces. And, again, I don't know how he deduces that outside the context of sentience if he's not putting it in that context, but I'm seeing it in the context of sentience. Everything that we perceive is in the context of sentience. That's the point. It's like, what is the context of physics? The mind. It's the perception is the context of our perception of the physical world. Like that's, and the context of perception is mind. That's what it is. And so I would say that a mind is a sentient singularity. It's a sentient being. It's a someone. Someone is perceiving and maneuvering. And there's someones within someones, just like you have cells within you. You are a cell within a larger being. That's the context that sentient singularity theory is proposing. So what would it be like to be a cell inside a body and that body moves? What does that mean for your perception of your world? What you do something and as a cell, and your body does something in response. Your body does something, and then your cells do something in response. What is this relationship that is occurring, and what types of perceptions would it cause to each other? To the cell looking out, being in a body and looking out, or being a body and having cells and looking in. That is what is the context of the structures that I'm proposing. And I think that that context is what is responsible for, at least, the perception of many of these structures in all of these structures in physics, all structures of perception, including the idea of, who, what, where, when, and why, this six-dimensional question string, essentially, these 6 questions. That's when I said it was a Calabi-Yau manifold. It's, a Calabi-Yau manifold is a 6-dimensional structure at every point in space and time. That means that it's a 6-dimensional structure at every point of perception, which means it's an information processing structure, most likely. Like every structure to some degree, but, the primary and secondary colors, the orders of operations in mathematics, who, what, where, when, why, and how. And many, many, many more, as I've showed on here, and we will get to it. There's a reason for this, the perception of these structures, including a 6-dimensional structure, including a 14-dimensional structure, including a 4-dimensional structure, including 3 generations, or 3 dimensions of space, even just alone, or 3 dimensions of time, if you think about it as past, present, and future. And that's how you're thinking of your conception of time as being 3-dimensional. So, like I said before with this, when we're looking at this structure, and let's say this is the universe, do you see the square? Yes. Do you see the squares? Yes. Do you see the wave? Yes. The questions you ask will dictate the structures that you see. So when people say, is it a 6-dimensional structure, or is it a 4-dimensional structure, or is it a 14-dimensional structure, or is it, a 3-dimensional structure? The will always matter. And it provides the context to the answer. There is no answer without a context. There's no question without, there's no answer that is possible to get without a question that is well contextualized. That's what I will say. Context is information. There's no information outside context. I'm trying to provide some context. And, this is not, Sentient singularity theory is not in competition with any other theories that are out there accept certain theories that have certain claims of about metaphysics and the fundamentality of sentience. If that's it. I mean, if you're going to claim that if you're Annika Harris and you're like, there is no you, and it's all you are an illusion, I don't think that is coherent of an idea, but that would be in competition with sentient singularity theory's fundamental assertions. But they're mathematical structures, what are dependent upon the question or the goal that you have. The question you ask or the goal that you have. If that makes any sense. Please let me know in the chat if this makes sense. I'm trying to be as impeccable as I can, and it's a little tough because I don't know what he means by there's two spaces and their relationship. There's a relationship between the two, or essentially, or it's relationship spaces between what, I don't know, but I'm gonna say whatever it is, it's due to it being contextualized within nested sentient beings. That's what I'm gonna say. So
I want to riff with you differently than I can riff with anyone else. I'm in the rare position where I'm talking to the only person who has actually talked about one of the great revolutions of our time that actually happened. When you did that show with Eva Miranda on geometric quantization, you took one of the three great developments in physics after the Standard Model, and you made it publicly accessible with Professor Miranda. So what is the situation? Isn't it amazing we had a revolution called geometric quantization and there's no trace of it?
Yeah.
In the public doesn't know, but for your channel, that it exists. And if you wanted to say it in a really funny way, it's that Hamiltonian dynamics, there are two ways of basically figuring out the consequence of a rule. If you use the Hamiltonian formalism, it self-quantizes. There's a thing called a symplectic form that generates how the world develops. And what we didn't realize is it comes from something else. It's the curvature tensor of a connection on a bundle over something called phase space. So we had this concept.
Just wanted to play that for a minute because I just want to say, that is a language that I don't speak fluently. I'm getting better, but it's not a language that I speak fluently. So that's why I'm trying not to overstep and make claims about his beliefs on here, but I'm going to state mine. So here.
I guess, look, it's embarrassing, but I just think we have a quantum fetish. And we have a tiny number of people who convince everyone to repeat the same statements about, the world is quantum mechanical. So if you say, I think the classical is more important, they don't hear that as an informed statement. They hear that as you didn't get the fact that the world is quantum. You still think that you live in a classical world. Or for example, the fact that, why does the classical world dominate? Why are we confused about the quantum world? Why isn't it evident that everything is quantum? It's Feynman voting. Have I ever talked about Feynman voting?
No.
Imagine that you have 10,000 people lost in a featureless landscape, and they're trying to figure out which way to go. And you've got one cult of like 1,000 people, right? So a small group of people, and they all agree. And you say, we're going to take a poll. We're going to add up. We're going to point in different directions. And then whatever the sum of the direction, we're going to average out by the number of people, and we'll go in that direction at that speed. Well, the key point is that everybody who's not in the cult is pointing in some different direction, and that's randomly going to average out to going in no direction at all, except the cult. And they're all going in this direction. So in Feynman voting, the classical thing contributes a much more coherent picture of what should happen. And that's why the classical world dominates, even though it's a minority perspective.
Okay, this is something that I will say I totally agree with. We have a quantum fetish. And the reason why we have a quantum fetish, as somebody who, fell victim to it to some degree and just would listen to me hours and hours of Michio Kaku in college, well, not even realizing that I didn't understand a word of what he was saying. I thought that I was being told about reality. But eventually now I'm realizing he doesn't even understand reality as well as he thinks he does. And certainly would disagree with probably a lot of sentient singularity theories concepts based on many comments that he's made about intelligence and mind and AI and things like that, and physics. But the reason why I think we have a quantum fetish is because the way in which it is described to the public doesn't make any sense. And the reason it's described this way to the public is because I think that even the establishment doesn't really understand that what they're saying doesn't make sense, or if they do, then they just write it off to saying, quantum mechanics is paradoxical. It's different, has different rules than the rest of the world. And you can see this when, and I've described this on here, this has happened many times to me, but even pretty recently, a few weeks ago, someone who is a physics professor, I'm pretty sure, or at least has a PhD in physics, on Twitter said to me, I said that probability was a tool that we use. It's a tool. It's not a fundamental law of the universe, of how the universe works. It is a tool, and that we use to make predictions when we don't have all the information, and try and maximize the likelihood that we're correct. And he said, no, actually, quantum mechanics is fundamentally probabilistic. And it just, that he says that's what the math suggests. And this is, again, taking us back to our scientific academic narratives have confused explanation with description. Math is not an explanation. It can be if your question is a quantitative question, but it's not in any other context really. Is it explanatory? It is able to still be descriptive though, because it is a language. And when people say I'm not good at math, I used to say that all the time too. And the reality is I am very good at math if I actually sit there and study the terminology, but it is a language. I remember the first math test I ever failed. I was ditching class a lot and I wasn't paying attention when I was in middle school, and we were learning about inequalities for the first time. And I went and I took the test, or I was given the test, and I looked at it, the equations, and when I say I was gone and absent and zoning out, I mean completely. And I realized I didn't know what these little, Pac-Man type signs meant, even though I should have, because, the whole class was learning about it for probably weeks on end. And I just sat there and I refused to do the test. And I ended up failing the test. And it was the first time I ever failed a math test. And maybe even a class. I can't remember if I failed the class, or I came very close to it at least. And I was just kicked out because I refused to do the test. And I was like, I don't understand. It's like if you handed me a Spanish test and I did not speak Spanish, then you should just, good luck. You will never be able to figure it out. It's not a matter of, are you good enough at math? It's, do you understand what those symbols mean? And I was never very good at it in the context of algebra in school because it was contextless. These equations were contextless. And that is what physics is these days. Most of it is contextless. And especially quantum mechanics and the symmetries within the standard model and the generationality of matter and all of these things that are built into, quantum theory have no context to them, including the perceived fundamentality of probability. And if you say that, and you say that the universe is fundamentally probabilistic, you do not understand probability or causation at all. Either from a first-hand perspective or from a second-hand perspective, at least within the context of, you applying it to physics, which means that you don't really understand physics because physics is about causality. But this just shows kind of the problem with quantum mechanics is it's been misportrayed in a way that makes it seem so alien, and that makes it seem so interesting, and also completely untouchable. You start hearing people repeat things like, oh, if you think you understand quantum mechanics, then you don't understand quantum mechanics. And I think that means that we have a really, really, really confused and lost physics narrative. If you're going to say things like that, or you're going to say that it's fundamentally probabilistic, that's a problem. So, but that's why I think we have a quantum fetish, is because what the public has been told seems so fantastical because it doesn't make sense with our firsthand understanding and our intuition at all. And I think that actually, if you properly contextualize quantum mechanics and you realize, that the space of this occurs within the space of bundles bundles within bundles, and overlapping or strings of information that cause excitation that can be perceived in a bit of information, which come within, from a certain perspective within the universe, it's going to end up looking like a piece of information that you cannot just override and overrule just by your own thought alone, because it's occurring in a space beyond you, and so therefore it's concretized and it's perceived as matter. And you're going to see an electron, you're going to see a quark, and you're going to see a neutrino, and you're going to see a photon, and you're going to see a gluon. It's like, what are these particles? What is the context of these bits of information that we are perceiving? And I think that a bundle space is the right way to think about it from a physical perspective, but I would say that bundle fundamentally is a mind, which is a bundle of self-referential information structures. I've showed on here before, this is Eric talks about this structure sometimes, the Hopf vibration. You find a window. This thing. It's just, it is amazing. It's odd. I don't know who made this. If you do, let me know in the comments below. But look at that. There's something so incredible about this structure. And any kind of structure that has more dimensions than just or is described in a way that to have more dimensions and or be paradoxical or kind of like not make sense in the physical world, they probably are information structures, which is mental structures. And this is something I agree with Annika Harris on, but I just disagree with her fundamental description of the fundamental nature of existence. I don't think that hers is coherent, but the idea that these structures like a Calabi-Yau manifold and like even bot periodicity, we'll talk about later, my theories on this, and even a four-dimensional initial structure, a four-dimensional manifold that is the initial structure, that is, coming from these four primary perspectives. These are all mental structures. When people say it's like a Klein bottle is like this shape that doesn't make sense in the physical world, or like a Mobius strip, or Penrose stairs. These structures are like, think about a Penrose stairs. Penrose stairs is a structure that appears to be additional, like you can go up and down. It's like adding information. It's you have just think about the degrees of freedom that you have if you were to walk along a Penrose stairs. It's like this endless self-referential Mobius strip of steps that you can walk up and down, but also is endless and kind of self-looping. This doesn't make any sense in our physical world, but it does in the context of the mental structures of a mind that must ultimately be self-referential eventually, but are also generative and relational, and all of these different descriptors that we have. So when you say we're a relationship space, or a space of relationships, or two different spaces, what does it mean to have two different spaces? Like we need context to these things. And Eric, he says it, I think, even in this podcast, but he's said it in many different, talks that he's given online, that ultimately any context that is given beyond the four-dimensional manifold that geometric unity starts with would have to be given by philosophers and theologians, or maybe a theistic philosopher. And I think that is definitely a requirement, even in understanding our quantum mechanics in a way that is intuitive, our relativistic physics in a way that is intuitive, even because there are some aspects of relativity it's more intuitive to us because we maneuver within relativity for the most part, but at least we don't see how we maneuver in a quantum mechanical sense, but we definitely perceive much more easily like a relativistic context of most of our physical movements. And so I think but there are certain contexts that's a little odd. And, when you start talking about time moving slower over here or faster over there based on, mass and speed and things like that, you can kind of get to a place where that is more intuitive, and it's easier than quantum mechanics, but it still would be much easier with a little bit more context. But quantum mechanics really needs context because it's missing it entirely. It's completely missing it. We provide firsthand to ourselves kind of an intuitive understanding and a firsthand understanding of what it means to maneuver through relativity, because we do it all the time in the physical sense. Whenever we are trying to maneuver in a space, we are doing it within the context of a relativistic perception. So, but that doesn't mean that there's no context necessary there. Just because we have the description doesn't mean that we have the explanation. Why do we perceive relativity from certain perspectives? That's a question that you need additional context to answer. And maybe GU starts to do that. And if it does, and it's only physical explanations that it's providing, Sentient Singularity Theory definitely seems to provide, or is an attempt at least to provide, the context to those perceptions. And I do think that it's very important that we start discussing this stuff in the right context. And Eric is always welcome on the show. That as is anyone who I speak about on here, and I say that all the time. But I, especially here where it's, I think, probably the best proposal currently for a physics theory that moves beyond our current, physics theories, and also seems to have substance to it that could possibly be not just adding additional context to to our current theories, but also may provide access to additional degrees of freedom that we don't currently have access to according to our conventional, current physics narratives and theories. And it's not these la la land. It's not a la la land theory. This, like, I don't know what that even means. La la land theory. This not kind of just, I guess, theory that is an attempt to answer something that it doesn't even really attempt to answer. Like many worlds from a cosmological standpoint, does not actually answer why the universe exists. But many people will be like, why does the universe exist? And it's like, well, really, there's an infinite number of universes, and all universes that are possible, exist. And we just happen to be in the one that allows for the perception of it from beings within it. And it's like, this didn't even answer the question of where did the universe come from? Or when people say, the Big Bang, where did the universe come from? The Big Bang. That's not an answer. And Piers Morgan, the best thing that he did in the interview or the debate with Eric and Sean Carroll was when he was basically making the argument for God, but I don't think Piers made a very good argument for God. I think there's much better arguments for God than what Piers made. I think that's actually a pretty bad argument for God. But still, even though I would agree with, the existence of God, the assertion of the existence of God, I don't think Piers's proposal for why God must exist was actually that coherent. But Sean Carroll's, though, answer was, actually, we can understand what happens beyond the Big Bang, and we are working very hard on that, and it is a good scientific question, and it's like, this is the idea that you have put forth a proposal for that without even an explanation for the physics structures that we perceive here yet. It just doesn't make any sense. Why an explanation for why life exists, even from the many worlds cosmological perspective, I guess. They're answers that don't actually answer anything. They're like it's just passing the buck. It's like when you say, this is a better example. I'm trying to think of better examples, but better example is when you say, how did life begin, here on Earth? Cellular life. By life, I mean cellular life. And people say, well, what if it didn't really start here on Earth? What if, it actually came here on an asteroid from another planet? And, there was a cell trapped inside an asteroid and it hit here, and that's how life got here. That's passing the buck. It's not answering the question that we're trying to answer, which is, how do molecules and chemistry end up causing the assembly of cells? That's what we're trying to answer. And it has nothing to do with outer space. Like, that question has nothing to do with, like, oh, maybe it was a different planet. The planet doesn't matter. That's what I'm saying. And this is something that's occurring in physics a lot. And it's not even known. And so we don't even know how to talk about it because nobody is talking about it. And when I say nobody, I mean like very, very, very few people. Like, you could count them on one hand probably, who are really talking about this in a way that is, meaningful and seems to identify some of the issues with even how we describe some of these questions. Like, I think even the question, what is the origin of life, is like it's just not properly contextualized, and you can't get the right answer. But regardless, it's a big problem. We have lots of big problems that I kind of just described. Let me go to the chat. We are still trying to figure out what space is. Exactly, like physical space. Imagine trying to mechanically understand what mental space is. Maybe we should mentally try and understand what space is, and realize that there is no such thing as physical space that has nothing to do with the mind, and mental space or mental space that has nothing to do with the mind, that is everything to do with the mind, and then physical space that has nothing to do with the mind. That's not possible to even claim to be able to perceive, at least, because the mind is perceiving and conceiving of physical space. So when we say, what is physical space, you literally cannot describe what it is without providing or proposing a fundamental context to it. And this is what I mean. It's like, when we say things like, oh, it's two spaces, we really need to also start thinking about what would be responsible for that even perception or conception. And sometimes that may mean like atheists talking to theists and theists talking to atheists, and us assuming, whatever idea you might need to in order to look for evidence of it. If you're an atheist or self-described atheist, which I was for 24 years of my life, so I understand. And by theist, I just mean existence itself is a singular sentient being that is creating additional sentient beings within itself. And that I'm saying is theism. And it is the context of sentient singularity theory as well. That existence is a singular sentient being creating additional singularities of sentience within itself. That's context. If you don't believe that, you think that's nonsense, and you don't have an alternative context, or if you even you're even watching this at all, when you're thinking about anything, you have to assume the opposite of your default assumption is, and then look for evidence of it. You can't be like, well, my default assumption is this, and so, and I already see evidence of my default assumption. Of course you do, but like you need to make sure that you are even understanding the other person's proposal properly and being able to steelman it, which does include assuming it's true for the sake of argument, and then looking for evidence of it. And true to not your understanding, like if I say theism, I mean existence is a singular sentient being, that all other beings and all of their perceptions and conceptions are contained within. And there's nothing outside that being, and no one else outside that being. That's what I mean by theism. But if you're like, oh gosh, a man in a cloud is just a childish view. That's not what I mean by theism. So you need to make sure that you're properly representing someone else's idea, and I'm trying to do that. I don't think Eric's theory, geometric unity, seems to make a claim on theism or atheism or theism, because he says that in many talks that anything beyond the 4D manifold that is contained within the context of physical structures would have to be explained by theologians and philosophers, which I think are truly actually originally the same thing. But then maybe we have to start thinking about the context of physics, make this stuff intuitive again, including geometric unity. That's what I'm arguing, is I think geometric unity makes sense in the context of theism. That's my claim. I don't know if he would agree with that or not, but I don't think that he seems to make that much of a claim on it, because he leaves it up to, he says, I leave that up to philosophers and theologians. Well, okay. That's what I'm trying to do. It's probably such a rant. I'm really trying here to speak about this as impeccably as possible. But again, you cannot even tell me what space is. You can say it's a space is a manifold structure of multiple dimensions, or aka degrees of freedom. Eric, once I was on his. I've had a couple conversations with Eric on various platforms, and one of them was on his Instagram Live once. And I said, and it was actually posted here, and I got a copyright claim on it and had to remove it. It was posted on the channel many years ago, and I removed it. If Eric is watching this, maybe let me know if I have permission to post that again. But it's on his Instagram from like 2020. And I said, if a dimension is a perspective, then what dimensions are you focused on in order to get like these structures that you are describing? Like where does a 4D Observerse come from? And he said, a dimension isn't a perspective, it's a degree of freedom. And what I would say is that a dimension is a perspective of either a degree of freedom or a constraint. It is a perceived degree of freedom or constraint. That's what I would say a perspective or dimension is. It's a perceived degree of freedom or constraint. And it took me years to like figure out how to say this, because I couldn't argue with him, even though intuitively I was like, I don't know how that's even, like if there's a difference there, but I didn't want to, hit limited time. And also I didn't know how to describe my thoughts yet. But I would say that my definition of a dimension is a perceived degree of freedom or constraint. And they are two sides of one coin. You cannot have a hallway without the walls or the floor or the ceiling. And so when you have, when he's talking about in the previous clip I was showing, where in Feynman decision making or whatever, he's like, there's a featureless landscape. And I give this example of like to describe choice all the time on here, and how choice is, I guess, choice or free will and determinism are codependent concepts. They're not actually mutually exclusive concepts. You need determinism in order to be able to make a choice. If there is a featureless landscape and everybody's pointing over there, or if you're going to try and decide where to go, let's say nobody's pointing, you can't make a decision on where to go because there is no over there versus over there, because there's no features to distinguish. So when I say, when I'm talking about choice, and I give them example of you're walking down a path, you come to a fork in the road, one fork path goes this way, one goes that way, or they branch off, but they don't lead to different spaces or different places. As far as you can tell, there's no difference in where they're headed. It's just a blank landscape. This leads into infinite blankness. That path leads into infinite blankness, and that path leads into infinite flat blankness. Then you can't actually make a choice. You can pull out a coin and flip the coin, but the choice is to flip the coin. The choice is not you choosing which path to go. And in the instance of the Feynman featureless landscape, if you're saying over there, if everybody's saying, let's go over there, and they're pointing over there to that random direction that they don't see any features that would necessarily like imply why we should go over there. The choice isn't to go over there or over there. It's to go where they're pointing or away from where they're pointing. There is no directionality perceivable or decisions that are decidable beyond the context of the other people pointing. They are the ones providing the context of the choice. It's not landscape that is providing the context of the choice. Nobody there, if you don't have an understanding of where you're going, I say this all the time, if you chase a headless chicken, then you are a headless chicken. Most researchers in most fields today are headless chickens. I know this from zoology and herpetology and biology, and I can see it in physics and in AI and so many other fields that I have, some of them extensive understanding of and some of them a little bit of an understanding of, enough to see this and this phenomenon. And what I'm saying is we need to provide features in the landscape if people are going to start being able to make a choice, because otherwise your only choice is to say, I want to go where everybody else is pointing. And some of those people have PhDs. Most of those people have PhDs. So why not follow them? Because I would assume they know what they're talking about. If I don't know what I'm talking about, why would I make the decision? It's like, we need some context, or else then who is to say who is right? Or what theory is right? It's like if all of these theories are beyond understanding of the public, then we will not move anywhere that is reasonable. And yes, I understand that like the mob exists, but that's just an inevitability of society, at least right now. It's not what I'm talking about when it comes to the change of direction in science. We need to provide context. And if physicists today do not understand the context of the mainstream ideas, then how can they understand the context of geometric unity on its own necessarily? I mean, I don't think that they really can. And I don't think I think they're wrong about the context that they assume. And so why would it even matter to try and convince them right now? I mean, they don't even realize how lost they are, most of them. And fundamentally, you don't have to be a physicist to realize this. You don't have to speak the language of gauge theory and I don't know, mathematics. and advanced geometry in order to perceive this. You just need to be able to understand the constraints of mind and thinking and language. And these are things that we all understand. It's like, okay, space. What is space? Why? Not even what is space. I think that we need to ask first, like, why is space? Like, why is space? We don't have an answer to that. And I think that inevitably you're going to first contextualize that within the context of mind, because that's who's perceiving space. Like the idea that this mental space is one thing and your thoughts are one thing and everything else that you perceive around you, that's the observable world that is objective. What's his name said this, that guy who was on with Dave Farina, the Professor Dave, on the commentary, most recent commentary I did on one of their, destruction videos. And they defined it. They defined science as the assumption of a mind-independent reality, which is not the definition of science. And this is why, though, there's no context to structures in physics, because no matter what, whether you're a theist and you believe we're inside a mind or not, and you believe that mind is emergent from inanimate, matter, whatever you think that is, ultimately, like, we are observing physics and maneuvering physics and describing physics in the context of our minds. And so there is no way to give any context to physics in a mind-independent way. There's just not. Now, in certain contexts, in Sentient Singularity Theory, you can add some context. You can be like, yeah, matter is the information that is perceived as beyond you or outside of you. And from a mental standpoint, it's perceived as being concretized in your perception, meaning like you can't just, there's a difference between seeing an elephant out there in front of you and thinking about an elephant in front of you. You can think the elephant away that's in your own mind that you're thinking about as being in front of you. If there's actually an elephant in front of you, you cannot just think it away. What is the context of that? Why is that? Why is it that, I can't just think the door open or disappear, make it vanish with my mind? We need to ask some of these questions, and you cannot ask them in a mind-independent context. So inevitably, whether you're an atheist or a theist or what, like, this needs to be part of the narrative. We need philosophers who are thinking about the structure of information processing and the structure of mind in order to start explaining why do we see, 3 primary and 3 secondary colors? Why is there additive and subtractive color mixing, and why is each of those composed of 3 different colors? Magenta and cyan and what is it, teal? Magenta, cyan, and yellow, and red, blue, and yellow for the color primary colors, I guess. And then color mixing, additive color mixing actually would be like your computer. So it'd be like green and red and blue. So a computer screen makes every color by a combination of green, red, and blue. And a printer creates every color combination by, or at least that's conceivable, by mixing magenta, cyan, and yellow. And then we have 3 primary colors as well, and 3 secondary colors that we perceive as well. Why is it this triadic, relationship of colors that exists in each one of these different examples? Why? That's not necessarily a physics question, even though it's a physics observation. It's a question about metaphysics and the information processing structures within a mind. Inevitably. And then it leads to a physically perceived structure. It's not physics. People say, oh, matter doesn't exist. It's just an illusion. No, that's not true. It's not even right to think about that there's ideas there and there's not matter. No, matter is what is matter? It is information that you cannot just override. It is perceived as concretized in your perception, meaning like you cannot just overthink it, basically. Just change the colors of the room all of a sudden. I don't like this color of these walls. I'm just going to think them to being a different color. No, you can't do that. And so why, though? That is a question that is very relevant to physics and theology and metaphysics. But it's ultimately always going to be a question that is contextualized within the space, at least partially, of mind. But quantum, guys, there's two components of causality in sentient singularity theory. It is determinism and choice. Those are the two components of causality in sentient singularity theory. There is no fundamental probability. But if you say that, then people will be like, oh my gosh, quantum physics. And then you get a quantum fetish. I went so many directions there. I hope it was a bit coherent, but probably had to stick it out through the end for it. Would you say mental space imagination is real? Yes, absolutely. Mental space imagination is real. It is absolutely real. I don't like the term reality. When people say, what is reality? Are we in a simulation? It's like these questions are not the right questions. You can ask better questions, but you need better context. You need context. We don't even have any context. I wouldn't even say that we need better context. We need context. We have none. So, are we in a simulation? What do you mean by that? Do you mean am I real? Am I actually like a sentient being? Or do you mean our universe may be running on a technological substrate in a previous universe? That, those are two different questions. One of them is a logical question. The other one is not. If you're saying, am I real? Or is this real? Is reality real? Or is reality an illusion? What does that even mean? What is an illusion? Other than just a misperception, I guess, if we're really going to properly define what people mean by that. But it's just perception. That's why do we perceive this? Why do we perceive this here? Why do we perceive that there? That's what we should be asking, not is reality an illusion? We haven't defined any of that. But I will say, if you're real, it's real. So why, it just makes no sense to ask, is reality an illusion? I don't think that the term reality is a good term, but existence is a better term. It's more properly contextualized in its definition. But even then, you got to get a bit more specific. So I agree with Eric, though. We need philosophers and theologians to start proposing contexts. And if anybody has a context that's not a theistic context, it isn't the context of a sentient being creating additional sentient beings within itself, and that physics is the perception of information by what we call physics is the perception of information by a mind that is us within a mind that we are within, whether that's the universe or God, or the universe within God is a matter of definitions, but of mainly the term universe. This is we need to start thinking about this more. The content, we can all realize you don't need to be a physicist to realize that certain questions don't make sense. Is reality an illusion? Think about that more. Think about what you even mean by that. if you were to ask that, or what other people even mean by that when they ask that. I don't think that they even know what that means, what they mean by that when they ask that most of the time. But matter exists. It's just the question is, what is matter? But the real way to answer what is matter is not, I guess you can, if you maybe what is matter is like the description of the different material structures, like different fundamental elementary particles or whatever. I don't even think that's a good term for them, but you know, the standard model. But maybe that, if anything, I guess if there is a definition for what is matter, I guess you could say it's that. But really, like, before you ask like what is matter, you need to ask why is matter, and I would say that you will get the answer of what is matter when you ask why is matter. In the right context, you will get the answer what is matter. If what is matter is like a kind of a explanation of why a certain particle is perceived in a certain and why its properties, the properties it has, are perceived, versus like what I guess, you know, what is matter would just be, you know, I don't know, like a math equation or something like that. I would say that's not a context that is truly explanatory. It's just not. Mathematics is not as fundamental as people think. It's not. Perception precedes language, and in many ways, language is perception, but there's a context to that perception that precedes or is fundamental to any linguistically describable structures, and that includes any mathematical structures, even if you're writing them in the language of mathematics, which is just a language. It's interesting. We place like physicists and mathematicians as like the people that understand the world the best from a scientific perspective. It's like, if you're a mathematician, people will ask you about everything. If you're a physicist, people will ask you about everything. I think physics actually makes more sense. But being a mathematician is really just being a linguist almost. Or maybe you could even say it's like almost like being, I would say it's like being a linguist. It's like you understand the rules, you speak a certain language and you understand the rules of that language. And you can speak it, you know? So there is an equation for a red basketball, specifically. There's many equations to describe a red basketball, actually. Just like there's many sentences to describe a red basketball. This is it's how much it weighs. This is its tensile strength. This is the color that it is. This is its you know, how many centimeters it is across. Like some of these are relativist. All of these are relativistic, but they are all equations. But you can give a linguistic description for each of these. It is this many centimeters across. It weighs this much. And then you can start building those things together, and you can say it weighs this much because it is this many centimeters across, and it is this thick, and it is made of this material, which has this mass. And then you're building a story or that is a description of, not even necessarily a story, but a description of this basketball. And you can do that in the language of mathematics, and you can also do it in the language of English or Hebrew or Spanish or Japanese or whatever. So I think that we're even looking to the wrong people for answers about the context of our scientific theories. It's not mathematics. I do believe that we can imagine what we can imagine can happen. And history kind of seems like that. We always image first, then we discover. Yes, but that doesn't mean that anything that we imagine is coherent. I mean, think about your dreams and you will realize that, at least within the physical world. At least, and within the context of our abilities to maneuver the physically perceived world, which is really the mind of another being. Like, their thoughts will trump yours. They can change information maybe on a thought, and they might say, oh, think, okay, actually, the elephant that I'm thinking about is elephants are no longer pink, they are gray. It's not Berenstain Bears anymore, it's Berenstain Bears, like if you're familiar with that whole, but and I don't know, I'm not really claiming that's a true example, but I do remember as a kid thinking it was Bernstein Bears, and I have the last name Goldstein, and I have had a friend growing up with the last name Bernstein, and I would have realized, I feel like, if his last name was different than the other. But what's really interesting about this, and this is kind of like a fascinating side thought, is if we were inside a mind, if you're inside a mind, which your mind is not a brain. You are a mind, you have a brain. They're two different things. And your mind changes its information structure, or it changes a thought within it, which means change the information within it. Then now all the minds within that mind will have to maneuver and contend with that information. And what that means is contextually dependent. But they will have to contend with that, your change in thoughts. Your thoughts affect your physicality and also your physical abilities, and they impact, the internal systems of your body, the cells of your body, and also, how you are able to maneuver the world around you. It just is a fact. That's why, again, I clean my desk up always, and this room, my office, before these streams, because I'm trying to be as coherent as possible. If this was chaos, it's just easier to be distracted. And that's a change in the physical world that impacts my mental space. Well, if the physical world is the mental space of the mind that we're within, then, and they change that information, then it would change what we have to contend with. And so, but the interesting thing is that, let's say elephants were pink in the mind of the universe, that is the being that is the universe. And then all of a sudden it was like, you know what, actually, I don't want elephants to be pink anymore. They're going to be gray. I don't even know if we would even realize it wouldn't look like elephants necessarily just changed in front of our eyes from pink to gray. It might not even be realizable in most contexts by us that the change occurred, because now we're still in the context that is their thoughts, essentially. So it's like it would become incorporated into the thoughts of most people. It's an odd idea, but I'm just saying there's some logic to it that is just meant to convey we are not, that there is no such thing as a mind-independent objective reality, especially in the context of you being a mind inside a mind. And so what is possible and what is imaginary and what is not imaginary, we need a context to it. So when people say, does imagination exist? What is imagination? Is imagination anything that is within your own mind alone? And doesn't impact others physically, even like the minds within you? Or is it just, is that even possible? Or is it just the information inside your mind and the beings that are inside of you that compose you that contend with that information? Like is it that your imagination is their reality? That's what I'm saying. This is a matter of definitions, and we really are sorely confused on a lot of this stuff, and we don't have as consistent definitions as we think we do for a lot of scientific concepts. And we need to get there. And next week or the week after will be a stream much more dedicated to that. I'm going to talk about, this guy, AI researcher named Elon, who was just recently on Curt Jaimungal's podcast, who I actually met at Mindfest, and I really like him. I'd like to have him on the show at some point. But one of the things that I think is going to be a central theme in that is, what are the definitions of some of these terms? Even on Twitter today, he said something. He was talking about language and how these LLMs are doing the same thing that humans do when we are, writing an essay, essentially. And I agree with him completely. And but he just defined it as, he said, they're not simulating intelligence, they're replicating intelligence. Intelligence is now within these LLMs. And I asked him, what is your definition? What is the definition of intelligence that you're using? And interestingly enough, Sentient Singularity Theory seems to always say there's 2 degrees of freedom in any decision. And so every decision that you make is a series of of decisions between 2 choices. Any choice you make is between 2 choices. It's not, or 2 possibilities. It's in how it's perceived. When you have A, B, C, and D on a multiple choice test, you say, well, it's definitely not that one, so it's got to be one of these 3. It's definitely not that one, so it's got to be one of these 2. And between these 2, it is probably this one because of whatever. That is actually 3 different decisions between 2 different choices. It's not actually a decision that is made in the context of 4 choices. And so, this is how information processing works. And so this is also relevant to physics. But when we have this, this constraint of the thinking process, that is the thinking process or the decision process by mind, this also applies to language. So there are 2 different definitions that you can choose between for any word, from what I've seen for the most part, and have both of them maintain coherence. And so you can't choose something that doesn't maintain coherence. Like the construction of language, every word you can choose, it means this or that, but it can't mean anything you want. It has to mean this or that. And usually one of them is redundant and not useful because it's redundant. And the other one would be, a definition that is useful and constructive. So intelligence is one of those words. And he's saying intelligence, these LLMs are intelligent. But he's not claiming it's that impressive, basically. He's just saying it's just this process. But that it is actually the same process that we're using, which I agree with him completely. You use this process, but that doesn't mean that you are this process. And when he says that an LLM is intelligent, I usually would say an LLM is not intelligent, even though we agree on that the same thing is basically happening. It's just a difference in choice of definitions. He's saying intelligence. It seems like he's just saying, and he hasn't responded to me yet, but I will get an answer from him. Is just coherent information chains, essentially, like coherent, which is really causality, like logical chain of causality, and most fundamentally. And that is, why even have a word? Why not just call it causal? Like, why do you need to call it intelligent? If it's just a math equation, but I would say that he would say that it's not artificial. It's not an imitation of intelligence. It is intelligence, but the process is just the same thing we do, and it's not that impressive. I would agree. It's not that as impressive as it seems, even though it's very impressive in how useful it can be. It's not that impressive mechanically on how it's working. It's just a math equation, and that it's not a good definition of intelligence, even if you did define intelligence that way, and even if it maintained coherence, because it's just a redundant definition at this point. Why not just call it a causal? it's causality, or it's just, you know, math. Why do you have to call it intelligent? Would you call a math equation intelligent? I don't think so. I think, and this is, again, like what is intelligence? I would say the better definition of intelligence, which is the other possible definition, is it's not just the ability for a goal to be achieved essentially by a process that maintains logical coherence. It's because you're saying a goal. It's not, it has to be like, intelligence is not the ability to accomplish a goal. It's the ability to conceive of a goal and accomplish it. It's not just the ability to accomplish a goal, because otherwise a calculator is freaking intelligent, because I'm the one providing the input, or I'm providing the goal and just pressing this deterministic little computational thing, and it spits out an answer. That's exactly what an LLM does too. And it's dynamic because it's constantly interacting with people. It's not like the calculator on your desk. But so the answers change a little bit, but it's self-optimizing, but it's not able to conceive of a goal and then achieve the goal. It's you that's conceiving of the goal and then achieving the goal by using an LLM as a tool to help you do it. And so this is, intelligence is, I would say, is a little different than whatever he's claiming it is. Or no, I wouldn't even say that. It's that, see, this is what I mean, is I would say a better definition of intelligence is different than however he's defining it. And it's the definition that I gave. It's the ability to conceive of a goal and then accomplish it. That is intelligence. It's not just the ability to achieve a goal, which is just, if you do that in a mind-independent way, it's just a calculator. It doesn't make sense. And this is exactly the same thing that's happening in AI, is the same thing that's happening in our physics. It's like, except it's oddly switched. For some reason, we think AI, which is just a better term, is dynamic algorithm. A dynamic network algorithm. That's really what it is. It's like a networked, it's an algorithm that we interact with in a network form, and it's dynamic, which causes it to be dynamic. And so, like, our terminology matters quite a bit here. So when we say things like it's a dimension, it's just a degree of freedom. It's not a perspective. That's probably impossible, or it's probably inevitable that it is a perspective. I would say that. I'm not going to say it's wrong that it's a degree of freedom. It is, but it's a degree of freedom and a constraint are co-defining of each other, and they are perceived. That's where differentiation is a perception. So again, like, this is what's so hard. The definitions that are being used, even by physicists, even by Eric, in that kind of exchange that we had many years ago, when he says it's not a perspective, it's more like a degree of freedom. And I agree with him, it is a degree of freedom, but I would say that it's even more so, like, more truly, a dimension is a perceived degree of freedom or constraint. And so this is why, like, remember, the context that of our models is our language. And so these words and these definitions, they really, really matter, and we got them wrong. That's my claim. Talk about infinity here being defined. Well, hold on. Okay.
I guess, look, it's embarrassing, but I just think we have a quantum fetish.
Hold on. So, something wrong with my link here. Oh, I see what's wrong. I accidentally have an extra letter. Here.
wired where a mathematician goes through something at 5 different levels. So then I give a specific example with Emily Reel, a professor of category theory, is known for being the top category theorist. She's been on the podcast before as well, on infinity categories. So this was her explaining infinity at 5 different levels. And actually, if you watch it, what she does is she explains something about infinity, like something that's unbounded, to a 9-year-old, not a 5-year-old.
Okay.
Then she explains Hilbert's Hotel to someone else.
Right.
And then she explains cardinality. And then she explains the axiom of choice and its equivalences. But the point is that by the end, when she's speaking to another professor, she's speaking about infinity categories, yes, and also how you can construct proofs by looking at one space is some domain, and the target space is a proof, and that's what a mathematical theorem is. And then, okay, so now if you look at it and you're like, okay, was that explained at 5 different levels? No. It was just tangentially concepts related to this that was explained at 5 different levels.
Because the internet has its own weird intellectualism that is horrendous. I mean, let's just be honest.
What do you mean?
The internet wants to know all sorts of things, and it believes certain things. Like, one thing it believes is that you can watch a conflict between 2 people on a topic that you can't possibly understand. And by looking at body language and who's sweating and all these things, yeah, he curb stomped that guy. No, both of them were wrong, and one of them was more polished. And, if I put my shoulder back, I appear to be more confident in my position. So the internet.
I think this is a great way of a great topic is like infinity that's related to what I was just saying. And these statements is like, and I will say it's beyond the internet. It's not just people on the internet that are that have this problem. It's so much more widespread than that now, and it's due to a lack of a fundamental context of anything that we're doing, of why we're here, meaning, physics, language, math. It's just, especially in this hyper specialized world, we really think that we can't know what's going on about in these hyper specialized fields, and like mathematics. It's like you don't speak mathematics, but like you just kind of assume that that the person with the PhD or who speaks most confidently or has the most accreditations or has published the most or works at the most highly rated university with the biggest endowment, whatever it is, like those are the guys that we're going to assume are correct, and we think that we can understand this. And that is not true, obviously. I agree with Eric. But it's even harder because we are missing the context of our language even. So good luck having a conversation about that is logically coherent, in which both people mean the same things when they say the same words. And then good luck to the people watching that conversation of whether or not they're going to be able to pick out a winner. When most of the people engaging in the discussion that they're watching don't even have certain concepts that are considered key concepts in their field, and are terms that are constantly used, not properly defined, like intelligence, like agent. It's like everybody's like an AI agent. What the heck is an AI agent? I asked William Hahn this, who's another AI researcher. I think him and Elon Benowitz, I think is his last name. I don't want to. I kind of want to like find out his last name because I might have messed it up, and I don't want to do that. Let's look. And I like Elon, and I'm really looking forward to finishing his podcast. I'm going to invite him on the channel because I have his contact information. But we had good discussions at Mindfest. But the theory that shatters a language itself, it's with Barinholtz. Elon Barinholtz. I think I'm pronouncing that correctly. Not Benowitz. Sorry. But like this, him and William Hahn, who's also been on Curt's podcast, I think, and I did a stream on his work as well, and I like him as well. He said AI agents when I was at Mindfest, and I asked him, I was like, what is an agent? What's the definition of an agent? He was like, I would say that the definition of an agent is every prompt creates a new agent. And it's like, but then why do we have the term prompt? You could just say the answer to this prompt or the response to this prompt. Like agent is a term that historically has been associated with the concept of agency, like meaning freedom of will, which means the ability to choose a goal. That is what freedom of will really is. People say, what is free will? And you have Sam Harris being like, oh, you don't have free will. It's just an illusion because you can't pick what, you didn't pick what you wanted to eat today because that you can't pick what your tastes are before you're born and what kind of, what you're going to like. And, do you like ice cream or not? Do you like chocolate or not? That's not up to you. And you didn't pick where you were born and what your lineage was and whether or not you were even born. And you're not picking the atoms that are arranged to make you or the cells that are arranged out of those atoms. And so you have no free will. And it's like, that is obviously not a definition of free will that is intuitive at all. And also intuitively understood, and also not if that's the definition of free will, then there is no free will necessary to even state the term, but we have a term for it. And so what would it mean really is, and so when I say, my definition is the ability to choose your own goals. That's free will. And I'm not even saying that you have it in every instance of your experience, but I think our experience seems to consistently confirm to each of us personally that we each have the experience of being able to choose our own goals very often, or at least sometimes. And yet, Sam Harris is very clearly defining it very differently. How are we supposed to have a conversation about free will if my definition is the ability to choose a goal and his definition is the ability to have chosen whether or not you were born and chosen what atoms you were made out of and what your parents' lineage was and what your taste preferences are before you finally make the choice of what to eat? That is not the same definition. The same thing is happening in all of our fields. It's not just free will discussions, but we're lacking context in all of them. And our questions and our assumptions are wrong, as Eric's saying when he says, I remember Eric actually said once, he said that he just hated something like he hated the engaging in these never-ending discussions is the universe deterministic or do we have free will? And I think that that's a never-ending discussion, just because it's the wrong. The question is wrong in its assumptions. It's incorrectly constructed because it doesn't have the right metaphysical context. There is no ability to make choice without determinism. Choice means a choice between two outcomes. There's no, if I choose to do that, if I choose to throw this over there, it needs to go over there. This comb, needs to go over there. You can't choose to throw anything in any direction if it's not going to deterministically go in a certain direction. And you can't choose which path to go down if it's not going to lead to that path in space-time. It is, the universe, causality has two components to it. One of them is choice, and one of them is determinism, but only within the context of an initial sentient being as the fundamental context. Is choice actually able to be a co-component with determinism? So this is why, I would say that that's a never-ending discussion because we have the wrong context. Same thing with, is a fetus the same body or separate body from the mom before it's born? It's it's both. But you've asked the wrong question when you say, is it this or that? It's this and that. The universe is deterministic, and the causality of the universe is deterministic and chosen. I'm proposing. So how are you hoping to make any progress on fundamental questions and the understanding of fundamental structures or the world in a fundamental way if you are missing the fundamental context? So, part of me, Eric says, okay, I'm going to propose this theory of geometric unity. And then after that, it's up to philosophers and theologians to explain the rest. Where does the universe come from prior to the Big Bang? What is Where did it come from? Okay, that's up to theologists, theists, or theistic philosophers, or atheistic philosophers or theologians to try and argue out. I would say you really kind of need a co-narrative to that a metaphysical co-narrative to a fundamental physics narrative, because you need to provide context to that if you're really going to get there. Like why a 4D manifold? Why do you start from a 4D manifold? Like Sentient Singularity Theory explains why you would start with a 4D manifold, but geometric unity seems to not. And I think that makes perfect sense for a physical theory that's a physics theory like geometric unity to start at a 4D manifold. But you would want to also provide context, if you can, that would be a proposal for why a 4D manifold as the start of the perception of physics. And I'm saying it's because it's the start of perception is a four-dimensional perception. All perception is four-dimensional perception. It's fascinating, but it's also tough to talk about because I have a context in my mind that is sentient singularity theory, and that's not the context that is really the context of any of the mainstream physics narratives. And I don't know about geometric unity. It seems like it provides some context that makes sense with geometric unity, but it's tough without to speak about this without feeling like I'm gaslighting somebody who didn't say what I'm saying. But I'm not. I'm saying I think this is the why to those things, and that it's actually you don't propose physics structures and then and have them be kind of more intuitively understood or understood really much at all, like in a way that's kind of stands on its own without a context to it. Quantum mechanics and general relativity have contexts to them. Our technology allowed us to perceive the quantum mechanics and actually make use of it to some degree. Not even to some degree. We created hydrogen bombs and fission power plants and things like that. Because we were able to observe it from the outside, we had a context. And we have a first-person context of general relativity as we maneuver through it. We need a context to the space that unites, to the structure that unifies these two perceptions. And that will inevitably be, I point to my brain, my head, but it's not, you are a brain, you are a mind, you have a brain. But what I mean is your mind, which is sentience, which is, it's more than just, a brain. Somebody said, I think one of the deep guys who maybe the CEO of DeepMind right now, I think it was him. He was making a lecture and he was like, I know that one day eventually AI agents and LLMs will be able to, I think he said, be creative or something like that. And because, or AKA have an imagination, because our brain is just a biological computer, and we can do that. And it's like, he's not thinking about this in the right context. This is why I want to talk to Elon instead of some of these other people. It's like the brain is not the context of these things, of information. Information is the context of information in a way, which is really mind is the context of information. And it's not the brain as a computer. Like information exists prior to the creation of computers, and apparently also prior to brains that are biological, right? Like Even a materialist or physicalist would say that. Okay, I need to go faster. How many hours have we been at this? I got way off track. Not off track, but just lost in the weeds. Is physical space and mental space different? Would you say mental space imagination is real, is happening in reality, or imagination? I would say you need to drop the term reality, is my whole point with that whole, a lot of what I had said earlier. I do believe that what we can't imagine can happen. Okay, you can change the lighting in dreams. I once, in a dream, my best lucid dream I ever had was I was in college, I think. And I realized I was dreaming, and I was like, if I'm dreaming, then I might be able to fly. And I literally was able to like put my arms out and like float. Literally, I say. But, and it was like kind of like, it felt like balancing on a balance beam more than it was like I was Superman. I just zoomed off. But I could do it, and I could practice it and get better at it. And it's like, try doing that in the physical world. And asking which one is real is not a good question. It's like they are just different. In spaces in which your perception is a different context. I guess one of them is within your own mind, and the other one is within the information processing of your own mind. Versus takes place in things that we do in the physical world take place in an information processing structure that is includes mechanisms and processes that are occurring in structures that are beyond you and that are your world. And so you can't just think yourself into floating in this world. I think universe would have to think about you floating, and you'd have to maybe even think about you floating for you to start floating, or maybe at least the universe would have to think about it. You can't just will your way into floating in the physical world. It's like Xbox Live versus, Campaign. You can just use a cheat code in Campaign, and you can also use one in Xbox Live, but like, you also have to contend with the causality chains that are being created by other players in the Xbox Live. And that's true of our physical reality, of what we perceive as physical reality. Whereas like your dreams are like Campaign. You can kind of just do whatever you want. And everyone in your dreams is like an NPC, like the people that you battle against in Campaign player on a game. It's a rough analogy, but it's pretty close to what I think is the difference between those are two different contexts. And what's fundamentally happening there to cause all of what is being caused is very different. It's very, very different. Don't expect to be in this relation. The next time my girlfriend seems upset, I'm going to ask her why is the matter instead of what's the matter. That's very funny. But you do that. You say like, what is the matter? And then she tells you, I'm feeling this way. And then you say, why? That's why is the matter. You're just skipping a step. But that shows you that there's a chain. You keep those questions. There's a sequence to those questions when they're linked together as well. It's like why and what. There is an order to it. Depending on the question that you ask, though, you have to ask the question first. You can't just say which one comes first, why or what. It's like, what is the question that's like, what is the goal in the string of questioning that you're going to ask? What is the context of the string of questioning, which is the goal, by the way. Goals are the primary contextualizer of information processing. I don't expect to be in this relationship very long. That's very funny. Yeah, no, you won't be if, well, maybe, and my wife doesn't like when I say what, because I have terrible hearing. So I'll be like, what? She'll just be so annoyed. I wonder if I said why. But greeting all true. or observer, that's a really tricky term. Observer is not a tricky term. It's just made to be a tricky term because it's used by people that don't really seem to believe that what is fundamental is a someone. Someone is an observer. There's no such thing as an observer that is not a someone. And the fact that that's not understood in our physics narratives is insane. It's insane. It's because we're prioritizing secondhand definitions and information above our firsthand understanding, which is never the path to coherence at all, which is not, if you don't have coherence, you don't have understanding. You must, to understand something, people will say, have a first principles approach to it. First principles requires you to have to consider the first person first. That's what I will say. Eric Weinstein, can you comment on working low energy nuclear reactors or cold fusion? I cannot. Nathaniel Hanks is more of a Brian Keating question. That's more of a Brian Keating question. Yes, it is. That's more of a Brian Keating question. He's an experimentalist. The question relates to new physics and topology and potentials, and there is a matter of fact that I'd like to see if he knows. It's enormous. If you're asking me if I know, or Eric, said it's an Eric Weinstein question. I don't know. You'd have to ask Eric. Thanks to you, by the way, for the stream. I only mean to be direct, not rude. No, that's fine. I'm very direct. It's no worries. But yeah, I don't. I can't really comment on like cold fusion at all. I don't know really anything about it. And low energy nuclear reactors, I don't know what you mean by low energy. Like I know basically how a nuclear reactor works and how fission works and how fusion works, but I don't know what you mean by low energy nuclear reactors. How is gravity related to fusion? I don't know exactly how to answer that question right now, but I have an explanation for why we perceive gravity. And then that's what I would say for now. It's like, if you think about the context of sentient singularity theory, imagine, like I said, you're a cell inside of a body of another being. Imagine you're a cell inside of you. That means that the body that you are a component of to some degree and navigate in is your world. The universe to your cells is the human body that you are embodied within. And now think about what happens when you move that body. If I choose to go over there and grab this cup and bring it towards me, what happens to the world that is being perceived by my cells? It curves, it bends, distances shrink and grow, and probably causality changes in perceptions of certain causal chains would change, which is just time. It's just time is just change, the perception of change, and it's like, what is time? We talk about there's 4 dimensions to space time. That's physics. Length, width, height, time. It's like, what the heck is time? What do you mean by time? Do you mean like assembly time? Like Sarah Walker and Lee Cronin would talk about with chemical bonds and atomic, crystallization, essentially. It's like, the crystallization of information in the material sense over time, all the way from, at least protons and neutrons all the way up to humans. Or do you mean like the perception of time? Or the conception of like the arrow of time? Or do you mean like the perception of time, meaning like the feeling of of time passing? Like, you have to define that. We don't even do that. And I think that like you need to provide context. And if you do that, you realize like certain weird things that you can explain about like the perception of time. If you contextualize it within the context of a mind, it's like, why does every year seem faster and faster? Because every year in how your mind thinks about that year is in relationship to all the other experiences that you have had up into that period that you've, kind of conceptualized and conceived of and contained in your mind. And guess what? When you are 80, a year is going to feel very different to you than if you're 8, because if you're 8, a year is an eighth of your life. And if you're 80, a year is an 80th of your life. So that's why every year seems like it goes by faster and faster. It's because it's a smaller percentage of the whole. And what could you even compare? We think of, a year, that's 365 days. And if you ask Neil deGrasse Tyson, he'll sit there and he'll go, a year, what is a year? It's when the Earth goes one entire rotation around the sun, which is essentially 365 rotations of the Earth, complete rotations of the Earth around its own axis. And it's like, this is what a year fundamentally is. Okay, I'm not saying that isn't, that is how we define a year within a way that we can kind of, a cosmic clock that we can kind of all look at when we want to see if we're aligned and figure out a way to meet each other at, Chick-fil-A at the same time. But when you're talking about a year as in like an experience of a year of time, it's not just like the planet rotating around the sun or the Earth spinning around its axis. It's what is a year is, when you think about it or you feel it, and you don't compare it to a year. You don't compare it to the Earth going around the sun, is what I'm trying to say. I really started to get a bit like confused on how to say this, but what I'm saying is, when you think about a year, you're not, and how long a year is, you do not think about it being the same. You don't feel it as the same or perceive it as the same length of time every single year. Even though conceptually you think about it as, the Earth is going around the sun basically with in relationship to its own spin. It takes about 365 spins of the Earth for it to completely go around the sun one time. And that stays pretty consistent. So a year is the same length of time every time. So, but that's not actually true in the way that we conceive of or perceive a year for us. That's why a year always feels faster. Each subsequent year feels faster than the previous, and why, a month, 3 months of summer used to feel like an eternity when you were a kid, and now a month goes by in a blink of an eye when you get older. It's because you can only compare it to all the other years that you've experienced. When you say, I think back on my year, you compare it to all the time that you've previously or all the experiences that you've previously had that you've called, 33 years compared to this 1 year. I'm 34. You don't say this year and then you compare it to how long the Earth takes to go around the sun. Like that, these are two different contexts. So you can't make the comparison mentally. You make the comparison of this year in comparison to how long last year felt, and the year before that, and all the years leading up to that, and how the last 10 years feels like a blink of an eye. But the first 10 years of your life felt like forever. It's like, that's the same context as your experience, not the Earth going around the sun. That is not the context of the experience of time. And so when people say time, it's like, what do you mean by time, actually? And I would say you're going to get to this point of, what is the context of this? And always part of that context is mental context of yourself, at least. And also the mind that I'm going to propose that you're within, but you might not perceive that as mind from within it. You would just perceive it as a structure. Do your cells think about them being inside of a being? I don't know. Does it matter? Maybe. Sometimes. But probably not all the time, but probably sometimes. We went way off for a while, but I hope you're finding this interesting at least. And it is important. I'm not just anybody that doesn't think that us getting the language right and the metaphysical context right, which means the fundamental nature and initial structure of existence, in order to properly, truly understand any physics theory that is proposed, including geometric unity, does not understand understanding well enough. I don't get why the sky is asking about nuclear fusion when you're talking about consciousness. Is he trying to be a big brain and show how smart he is? Why this guy is asking about nuclear fusion? Oh, I don't know. Maybe he's just curious. I'm trying not to be offensive. I'm just trying to figure out the purpose of the line of questioning. People can be curious about all kinds of questions. Are you familiar with Michael Levin's work? Yes, I'm very familiar with Michael Levin's work. I went to Mindfest and helped film the kind of the recent lecture that he did that's posted on the Ekkolapto YouTube channel, I think, and also Curt Jaimungal's channel. I'm really familiar with Michael Levin's work. I think it's groundbreaking. It's very much aligned with Sentient Singularity Theory's kind of conception of a more fundamental biological perspective on biology. Michael Levin is brilliant, or has many brilliant ideas, and I really like his work. The fusion question is, okay, Jaimungal. Is Curt here? I didn't see Curt. Not all Jaimungals can study physics like you in India. I don't know if, I guess people are same thing. I think Curt is in Canada, guys. I feel like people are either assuming Tyler is Eric Weinstein or Curt Jaimungal, or they're trolling. Oh yeah, that's what they're doing. They're trolling me. I get it. Well, they're not familiar with this channel. This is very normal. Okay, so we can let's go to the next clip for those who want to hear from Eric and Curt. We meet out destiny. Okay, I'm gonna skip things because I've been talking for too long. Okay, here.
Why don't you just submit things? It's like, maybe you don't understand the critique. You haven't succeeded in over 50 years moving the Lagrangian of fundamental physics. Do you understand that part of the critique is the way peer review works, the way credit is apportioned, the way disputes are adjudicated is the problem. Your culture is decaying. You are no longer the people who are able to do the standard model. You've accepted such a degraded state in your culture that your institutions are repugnant to me. I don't apply for your grants either. I would love for GU to be evaluated with my H index as low as it could possibly be. If I could have an H index of 0, if I could do this with no PhD, I'd love that. But everybody pays lip service to, no, nobody cares where it comes from, nobody cares about it. But everybody does. We're a deeply hypocritical culture. We don't realize we've abandoned science, we've abandoned mathematics. We have, where we used to have the scientific method, we have what might now be termed the academic method. What's the impact factor? What's your H index? It's like, who cares? What's Gödel's?
Why? Because of everything I just stated. We lack fundamental context to all science. We lack a fundamental context to all science. Like, I've talked about this on my Theories of Everything, the how-to guide video. There is a first question, like, to all questions. And there is a second question of all questions. And that second question, at least, is what is the truest thing that I know? And people don't ask that when they start thinking about the context of physics and math. I would say we have not abandoned mathematics, but I just think we don't understand what mathematics is anymore. We've miscontextualized it. It's just a language. But we have abandoned science as anything useful other than just like this narrative that we all kind of, other than like, what did he say? It's it's not the scientific method. It's the academic method or something. It's like, what is your H index? How many papers have you published? And the reality is when he says, I'd like to do this with as low of an H index as possible, I think that's actually great, because let's think about this. If you have published more papers on physics than anyone else, and even if those papers have been accepted and peer reviewed or whatever, it doesn't matter. And those papers have not led to a single new physics discovery that is physically observable or applicable, it's just like equations that have been peer reviewed apparently to be physics. Like that implies that you really don't know what you're doing, and not just that, but nobody who's judging you does. They don't know what physics is, and neither do you. You should be probably. It's like the higher your H index and the less you are, if you are not actually making progress in fundamental physics, but you're a theoretical physicist, then the least credible of a physicist you should be, or the less credible of a physicist you should be considered, because you are proposing all these things that don't end up panning out, which is evidence not that to your correctness and your brilliance and the truth of your ideas, but to a lack of substance and a false context and an incorrectness of many of your assumptions that frame whatever structure it is that you're proposing. That is the opposite of every thing that our current society expects. And because we have a lack of context, and it means nobody can intuit anything anymore if you're not within the field. And even if you are within the field, if that field lacks context, which is almost every field, then you can only contextualize any ideas within the context of whatever already exists in the field, which is limited. And if you're talking about physics, like, you cannot just contextualize ideas within language. This is a fundamental constraint of physics that is kind of a little different from mathematics. It's like mathematics is able to be contextualized within mathematics. Physics must be contextualized within physically perceivable, concretized constraints. That's physics. It cannot just be within the context of its own self, like math and language, even. But eventually, if it's within the context of its own self, you will kind of devolve any field. But it needs to be built on a fundamental foundation. But you can kind of pass the buck longer and longer on mathematics than you can on physics. And this is why physics has become mathematics. And I don't need to speak mathematics in order to realize that, because I study the metaphysics of information, which is very relevant to language and causality, which is mathematics. So, yeah, I mean, this is why we're like that. But I agree with him. I think we should be like, the people who do not have a PhD are the ones who should be treated most credibly. There is actually a logical way of figuring out which theories to focus on. Do you come from outside of the establishment? I actually think that this is a point for you. It's not enough of a point for you to be meaning you're right. But if you're coming from inside the establishment and you still haven't convinced anybody, or maybe you've convinced everybody, but not even that has been able to lead to any applicable progress, then you probably are incorrect. And so is the entire establishment, most likely. And so, like, you shouldn't be looking to them. Like, the more papers you put out, the more evidence it is against your expertise if you're not actually making provable progress in the manipulation and maneuvering of physically concretized constraints and degrees of freedom. So, but also other things that would help you prioritize which theories to focus on, which ones not to, is which ones seem to come with additional applications, essentially. Like Eric says, GU might allow you to maneuver in temporal dimensions to some degree, or within space that in a way that isn't constrained by the constraints of general relativity. I don't want to say warp or anything like that, but just allow you to take advantage of more fundamental constraints and degrees of freedom than general relativity. And that is a point for why your theory should be looked at. If somebody says, this is my theory and it's useless, which, by the way, serious mathematicians and physicists have done this. There was a guy who literally did an entire TED talk on it. He said, this is my theory of everything. He gave his whole thing and he said, what does this mean for you? And he said, and he goes to the next slide. It says, absolutely nothing. And it's like, then your theory was a waste of time to listen to, because what we matter. It's not just about learning the truth, quote unquote, unless I don't even think that it's value. When people say the truth is intrinsically valuable, I think that valuable is defined, and you can't just say the truth is intrinsically valuable even if it's not applicable. It's like, no, if it's not applicable, then it's not valuable. And I actually think that all truth is, if it's proper, if you understand it properly, and it's meaning like you understand the proper context of it, it is valuable. Meaning it's applicable. And you need you don't need to know how we're going to maneuver these dimensions necessary or whatever, but like, you can't just be like, oh, maybe string theory will lead to warp drive. It's like, why? You got to tell me why that might be the case. You can't just say maybe it will one day. So here. And last thing that I will say to reference that clip is when he says, you people aren't the people that did this, that conceived of the standard model or created the standard model. No, they're not. No, they're not. And I don't think that they even realize how lost they are. And because they have no context to cling to except the academic accreditation itself and the structures that were created by other people. And those people are all dead for the most part. Like maybe Roger Penrose is like maybe the last one, and that's it. Of the, fundamental physicists of the previous century that actually had, some type of, were able to make some type of progress that was truly fundamental and real. But those people are gone. It's Steve Jobs built Apple. Tim Cook did not. Steve Jobs is very different from Tim Cook. Sundar Pichai is very different from the guys that founded Google, Larry Page and Sergey Brin. All those guys dropped out of college and built something. Everybody who ends up being the CEO now went to an Ivy League school and did really well and got good grades and never dropped out of college. Nobody who drops out of college ends up becoming the second CEO of a big company. They are usually the first CEO, but they're almost never the second. And you will see a difference in how the company, what the company does anytime this happens. They do groundbreaking things when the founder is in charge, and when the founder leaves, it's no longer even one man's vision. It's just like this disk, as Eric Weinstein, discusses, like the distributed ideas. It's not the disk. I mean, it is, but it's, what's this other term? It's the ego, the embedded growth obligation takes effect, and it's like everybody's little like personal goals come into play and aren't trumped by a single person's goal. And their person leading at this point is not somebody who has any new ideas, and they just want to, and if they're just not an outside the box thinker, otherwise they would have not become the second CEO due to having a high GPA at an Ivy League school. It's just not the same people. It's not. Einstein was a philosopher who worked as a patent clerk. Okay? He's not, like, him versus Sean Carroll is very different. Here.
If physics is serious national security, and if you fail at it long enough, you just think it's an academic subject. But this is so dangerous, this is so powerful, that we go to a movie called Oppenheimer, and we see, like, oh, there's Feynman, you know, there's Beta, there's Teller. Yeah, all those guys, you know, wiped out 2 Japanese cities. This is no joke. And we don't connect it to what we do because what we do doesn't work. This is what I call nerf physics. I don't know if we've ever discussed this.
No, but I want to get back to, so you wanted access to the archive, right to access.
Mhm.
They said you need an edu
Yeah.
email address. They then said, well, we'll make an exception for you. And then you didn't.
He goes on to talk about nerf physics. And I forgot what it's like all of Eric's things, like ego and is embedded growth obligation, and DISC is distributed idea suppression complex. Nerf physics is like something, it's another acronym or whatever it's called. I don't know. But it also has like this secondary meaning of like nerf physics is like a nerf gun. And it's not dangerous. You know, it's like fake play physics almost versus like real, you know, there's a difference between shooting a real firearm and shooting a nerf gun. All of our physics has become nerf physics. I agree with this completely. And for the same reason, it's because it doesn't work and it doesn't connect to our real world. Any subject that is in which real progress is made regarding our understanding of physical systems, and not even just physical systems, but true information systems that are within a context that is not just information itself, meaning like anything beyond just mathematics within math or language within language, is extremely dangerous. And the reality is language is never just within language, it's within conceptualization, and that is extremely dangerous. Ideas, even in philosophy, are extremely dangerous. And if you don't believe that, then like look at the rise of meaning, the feeling of meaninglessness, the lack of pursuit of marriage, and the chaos that is our dating world, and the the just the crisis of meaning that is everybody keeps talking about. It's like this is due to bad introduction of bad or aka incorrect metaphysical assumptions, and or you know, a lot of confusion that happens in our social and dating dynamics right now due to the definition of words. And yes, there is, you have a choice in how words are defined, but like, again, you have really 2 degrees of freedom in how they're defined. It can mean this or that, but it can't mean anything. And this has led to serious catastrophe on on the social space. And that's my main concern with sentient singularity theory and my metaphysics work. It's not in how do we go to other galaxies and other planets and other galaxies so that we can escape, you know, and find a different atmosphere than this one. That's not my main concern, even though I do think geometric unity might allow for something like that. Or at least some type of maneuverability of space-time without maneuvering through space-time. I think he even says something like that, but that's not me copying him. That's actually like a good way to say it, is like, it's a difference between moving from one point to another in the cosmos, which includes causality and on kind of on 2 dimensions, which is like in a chain of lineage, which is time, or in like a relational way, which is space. And Eric says that geometric unity would allow for, you to go from here to here. Maybe that's through, from the past to the future, future to the past, or whatever, or past moment to, from here, current moment to a past moment, whatever that exactly means. or to a future moment, or from this side of the galaxy to that side of the galaxy without going through it. So you can go from this place to this place without going through space, and you can go from this time, this moment, to this moment without going through time. And this has enormous implications on and dangers that are associated with it. I think that even proper philosophy and metaphysics can have this as well. I mean, there's a lot of misuse that can be done when you know enough about how something works, but not why it's there in the first place or why it works. I guess when I say how and why, I don't mean like what was the goal of that structure or of that process versus, or the goal for that process versus like the mechanism of that process is the how versus why. When we even ask why in science today, in our scientific narratives, we don't mean why when the same way that we mean it in a theological context. If you're having a conversation at synagogue or church or mosque, and somebody says, why is this like this? What they assume is like it's due to like the intentionality and a goal of some being greater than you. But if you're in a scientific discussion and you say, why is this like this? What they really mean is like, how is this like this? And when they say in science, when they say, how is this like this? They really mean this is like this. It's like just descriptive. It's not explanatory. It's interesting to realize, but like, it's like you're missing a whole context in our scientific narrative, which is will. So regardless, that's for another discussion later, but it's important to realize like how much that can change the language and your understanding of language. That just contextual change of sentience as fundamental versus not. That changes what why means. Isn't that crazy? That's insane. I mean, it's not, I don't even want to say insane or crazy because I hate those terms. Those are not good terms. That is incredible and like far-reaching in its implications. Okay. And given that, this
is broken, and I refuse to be referenced to a system that can't buy a base hit in 51 years, 52 years. It doesn't work. Why do I care about my colleagues' opinions if they're not leading physicists? The leading physicists of today are not leading physicists. There's no proof that they're doing physics. Like Frank Wilczek, I recognize him. I talked to Frank, right? In general.
Bingo. There's no proof that they're doing physics. Where is that proof? You know, like where is that proof? I actually think that you can contextualize a lot of manifold structures that seem to be abstract, but are actually mental structures if you contextualize them properly, like a Calabi-Yau manifold, or loop spaces and all these, you know, or a Hopf vibration. It's like, what is that? What is a Hopf vibration? It's a fiber bundle. No, you just described it again. What is it in a way that I understand it? Is it a mind? What is a Calabi-Yau manifold? Is it a series of 6 symmetries of information that exists in every point of perception that I have and you know, conception? Like who, what, where, when, and why, and how? Or you know, red and yellow and blue and green and purple and orange? Or parentheses exponentiation, which is really like concatenation, exponentiation, addition, multiplication, division, addition, and subtraction. Is that Calabi-Yau manifold? because it seems like it's like everywhere I look is there's this like 6-dimensional manifold. But if there's not, if this is not in any kind of context, then just like, what the heck is a Calabi-Yau manifold? But you can relate it to physics now if it's actually like a mental structure where you can say, okay, now I have a context to why we perceive these colors. A lot of physicists will be like, no, color is just like a wavelength of on the spectrum. And it's like, no. Like, we are trying to perceive differentiation, but in a way that is more fundamental than the spectrum or than relativity. And that would be kind of a symmetry manifold type of context. And that would be like, you'd be thinking about color mixing as the 3 additive and 3 subtractive colors to color mixing, and the 3 primary and 3 secondary colors, because this is what we perceive. We don't perceive ultraviolet. Like, when we're thinking about color, we don't think about ultraviolet as a color. We don't think about infrared as a color. We don't perceive that. So, but this still helps you relate and start building like explanations for why we perceive certain physical structures and also mental structures because of mental structures. You can't do this. I don't think that you can divorce physics from metaphysics. And by metaphysics, I mean like the mental space of mental possibilities and relationships. I don't think you can. And I think we have. And then it's led to nowhere. It's funny because Eric quotes Einstein when he starts geometric unity, and he says, something like Einstein said, and his greatest question was, did God have any choice in the creation of the universe? And he says that, and he makes, I think geometric unity is making progress in physics actually for the first time in a really long time, like major progress. And then you have Einstein, who nobody would deny made significant progress in physics, and he thought about the philosophical context of this being within God, created by God, be created by a being. And people can say, no, he's just a metaphor. He really just believes in the God of Spinoza, which is the God of science and math and stuff. And it's like, no, that doesn't matter. He asked the question in the context of choice being possible. That's not the God of Spinoza. So even if you asked him in a different context, you believe that there's a being that loves you and created you, intentionally. And even if he said no, that's not the point. The point is that he asked questions like, did God have any choice in the creation of the universe? And sentient singularity theory seems to suggest there's almost no choice in the laws of physics by God. In my own work, even. God is the most constrained being that exists, also the most powerful being, but also the most constrained. And so sentient singularity theory implies, just, we can get into it later, another day, but that there was no choice in how the universe was created, essentially, but it had to be chosen in order to be created, which really a better way of describing this is God had no choice in how the laws of perception and conception manifest and exist, but he had to choose how to create multiplicity of sentience within his oneness, because oneness was the default, because existence is by definition all that exists, meaning it's one. So existence initially is inevitably one beyond the beginning. And so creation of multiplicity goes against the nature of existence because it goes against the definition, the initial definition, which is the initial nature. And so so it's kind of this weird paradox of, not paradox, but like superposition of he had no choice in how to make the universe, but he had to choose to make it. But even then, it's a little bit more like you can get a little more accurate in how you phrase that. But the point is like they're not asking these questions in physics today. I've showed that clip of me that got me blocked by Sean Carroll, and many times on here, and this was it really quick for anyone who's interested. And it just shows a very different, like,
if you did believe that God was a necessary being, that you literally could not imagine a universe, if you did believe that God was a necessary being, that you literally could not imagine a universe in which God did not play an important role, in order logically for me to refute that belief, all I need to do is to invent a universe in which God does not exist.
Invent a universe in which God does not exist.
So according to Sean Carroll, all we have to do in order to show that a conscious creator is not necessary to the existence of a universe is consciously create a universe. Does anybody else see the problem with this? This is very different perspective than Einstein had when he was approaching physics, clearly. And I think that you need to ask questions like, did God have any choice in the laws of the universe in order to get a coherent answer? If you assume that there was no initial cause, how can you even do physics? How can you even do physics without any cause of causality itself that is being proposed? It's just, it falls apart. I do think that this is like why physics is so lost, partially. And I think that Eric, even if he calls himself an atheist, if he is starting his paper with this question, even if in another context you don't think that you were created intentionally by a higher sentient being, but you use the concept in your, in order to contextualize how to approach certain questions, which I'm assuming he does because he, in the way he describes things, like says, it's a series of relationships, and it's like relationships, like what between what, or he starts his paper with that Einstein quote. And it's like Sean Carroll would not do that. But I don't think that Sean Carroll would ever make the progress that Eric has made with geometric unity either. But they're not doing physics. They're not, because they're not trying to map the constraints of causality itself, because they don't know how to do that outside the context of what we currently already understand, because they don't know the initial context of causality itself. That's my proposal. And you don't have to agree with it, but I want to hear yours if you don't agree with it. And I do think it is necessary to at least propose. Even if you're just going to say it's, just for the sake of argument. Okay? Just recognize that, like, if it starts to work, it starts to work. And maybe there's a reason why. But if you're not impacting the physical world, then your ideas, like, you are not doing physics, and you're doing nerf physics, which is not even physics. I think that's what he called, that is not even remotely physics. That's I have it written down here, actually. That's funny that I said it without even trying. But yeah, not even remotely physics. Yeah. So nerf physics is not physics. And that's what we're doing. Not what we're doing, what they're doing. This is where GU gets very interesting.
So then this was my other critique, Hebrew. So there are other letters that are used not much by mathematicians other than in cardinality, Hebrew letters that were used in GU. So, and then there were some that I chose to keep in. And if I was to introduce this to certain people, and I don't have that same relationship to those people, so I don't honor them, even though you're honoring Trammell's your explanations. It's that communication gap I mentioned. your explanations. It's that communication gap I mentioned.
Pi is my wife.
You can watch the full video for that. Actually, that was not what I was trying to do. This is the one that I tried to copy.
The difference between 0 temporal dimensions, 1 temporal dimension, and multiple temporal dimensions is enormous. With 0 temporal dimensions, you're in elliptic theory, and you have access to a T.S. Singer and all the great stuff that comes from that. If you have 1 dimension, we know a lot about Hamiltonian dynamics and development and initial conditions. Problem is, if you have 2 or more temporal dimensions, you're in something called ultra-hyperbolic equations, and very few people can think in 2 or more temporal dimensions. GU has several things. This is something that, like, it's a great pleasure to be able to talk about. What am I critical about GU? You know, like, that's not a question that I get much.
I didn't ask that, but I'm curious to know. I'm glad you asked that of yourself.
So, for example, I don't know how to deal with ultra-hyperbolic equations. So if I think upstairs on the 14 manifold, there are no initial conditions because that's a codimension 1 concept. Really what you have is boundary conditions. And now, good luck. I think I had to be told that the Cauchy problem was well posed in ultra-hyperbolic equations. It's not something but this is not stuff I know. So it's a good example. The entire concept of physics is that I have an initial state.
Wouldn't that mean there's no Cauchy horizon?
I believe that they are well posed, but I don't know how to push Hamiltonian dynamics in multiple temporal dimensions.
Is the bundle trivial?
Which bundle?
The metric bundle.
Depends on the topology.
Well, the reason.
Okay, again, I'm not a mathematician, I'm not a physicist, but I'm going to try and add in what I think might be relevant context to this within my framework that I'm proposing is correct to some degree, not all of it, but like the general framework. We have to start thinking about what is time. When we say what is extratemporal dimensions, what is that? First, you have to think about what is time in the way that we're trying to think about this. So first, you have to think about, even before, in order to understand what time is, you have to say, like, what is your goal? Are we trying to go back to a previous moment, back in time? Like, or are we trying to, like, what are we trying to do when we think about this? And you have to add that kind of context. But I would say that time, in a kind of a more, it's not even in an objective way, but it's in a super subjective way, time is just change over, like a chain of change. It's cause change. It's choice and causality, or choice and determinism that basically are the two components of causality that are framing change and a chain of change. And so chain of change is certain events that are built on previous ones. If you listen to, if you use language and you're like, time is this, then that, then that, then that, essentially. And, but it's not really this and then that and then that and then that. So, the creators of South Park did made a video of behind the scenes. I forgot exactly where this one clip is from, but you can look it up on YouTube and you can see them talk about this. And they said, the way to have a terrible movie or a terrible story is and this is like, all the new Star Wars movies. It's like, first this, then this happened, 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 then this happened. And you're saying that, like, okay, this thing happened before this thing, and this thing happened before this thing, this event, but they're not connected in any way that is intrinsic. And that's why you end up with a shitty story. This is what, a lot of cinema has become. This, and then this, and then this, and then this, and then this. And they said, if you want to write a good story, what you have to, which really means coherent, a story with determinism in it, with stakes, because stakes require determinism. There has to be consequences, which consequences rely on determinism. So they say, instead of this and then this and then this, you say this, therefore this, therefore this, therefore this. And that is also, I think, a good way to think about time. But again, it's within the context of, both causality, and also I think you have to have a starting point, which requires putting it into the context of sentient being, the perception of a sentient being, the goal of a sentient being. And so what if a timeline is a chain of causality that is connected to such a degree that you could perceive it looked at from the right perspective as one structure, like a one chain. And yes, everything in the universe is somehow eventually connected to everything else in the universe, but not necessarily in a causally determinative way. There might be a limit to the effects of my actions in, right now might have a limit and might not actually impact, like, the butterfly effect might not be completely unbounded because there is also the context of sovereignty of sentience within this context of sentient singularity theory, which is basically like, if it's like a boundary of causation to some degree, because you can stop. If my cell decides to go metastatic and abandon its responsibilities and just try and live forever, it will result in my death, or I can cut it out. And so if I'm aware of it, then there's a boundary limit to like what it's able to actually do. And same thing with us and the universe that we're within. So like maybe the time in this context of a chain of kind of causality is there's different chains that to some degree, yes, they're all eventually one chain, but like when you're starting from a certain context or a certain act, which would be a certain action that gives context to the chain that we're looking at, that might have that view, that chain has a boundary of its causality, if that makes sense. And if causality comes from action by a sentient being, then, and there's multiple sentient beings in the universe, and not just me versus you, but the universe and us and our cells, and there's us and our cells might have time between the perspective of one of our cells and us, that might be two times. And us in the universe, that might be 2 times, like their perception of causality versus our perception of causality to some degree. That might be 2 times. I don't know. I realize that's very like, it might be pretty vague, but I think it's still more specific than I've seen proposed yet on what this would mean for there to be like 2 times, 2 temporal or an additional temporal dimensions. And but when you think about that, and then you think about how those times would interact with each other, maybe you could exploit like certain degrees of freedom to, move in a way that from one moment to another that is not currently conceivable. And again, you need to get the language right, or you will not be able to even conceive of this stuff properly. And that's the problem, is like you need to put this into the right context that starts fundamentally. And hopefully it's accurate enough to allow you to construct language that allows you to actually describe and, internally first, which is to conceive of something for a being like us that, once you're an adult, you just conceive of everything in words. And then, start to communicate that idea. We don't have that language. And it's partially I'm proposing because we don't have the fundamental context to start even properly defining what it would mean for there to be multiple temporal dimensions, because we're only looking at it from our own perspective, which is, then that's my clue here, by the way, is like we say, if there's 2 times, it's like, well, what we're in our current physics narrative, we have length, width, height, and time, or XYZ and time. And why do we have that? Because that's what's within our perception. Okay. But what if you've got 2 perceivers in a nested relationship, and each one of them has its own perception and is responsible for its own chain of causality that ultimately are interacting and overlapping, but also to some degree separate in their origins? I think that this might be on the way to making sense of this a little bit, but it might not. And I'd be fascinated to know Eric's thoughts on that. But let me know in the chat if that is interesting to you. But like we need, that's why I say context is so important, and language is so important. What you call something completely constrains or highly constrains how you conceive of it. That's why sentient singularity theory has the name that it has. And that's also why I think that the geometric unity is such a good name, because, you have, the graviton essentially that's been proposed for the answer to quantizing gravity, that basically there'd be a force carrier particle of gravity that you'd be able to perceive if you, as a small particle, as a boson. But we don't see that. And sentient singularity theory seems to suggest that that's not the way that it works, and that what it would really be is that we are inside the graviton. If the graviton really were to exist, and it really were to quantize gravity, meaning like be the force carrier particle of gravity, the force of gravity, it would be the universe itself. It is, that seems obvious to me, but it's not obvious to Sean Carroll and these people, because they say things like, as Sean said, we should expect everything to eventually be quantizable, because the world fundamentally runs on quantum mechanics. And it's like, you don't even know what quantum mechanics, why we perceive quantum mechanics. So like, do you even know what it is, really? Like what it is? What's going on that causes that perception that you are having? I don't think they have a clue. Some people do, like you listen to Bernardo Kastrup and he's like, it's an excitation of a string on two overlapping fiber bundles essentially. And I agree with that. Like, that's what I think it is. It's like two crossing strings. Like a violin. It's like you cross one string with those strings and it's like, or even this, these strings, it's like, if you think about what you have when you're like making it's a very awkward angle, but like, and I'm not very good at ukulele either, but like what's happening is you're having like one thing impact another, and it creates like sound. Same thing with the violin. It's like one string crosses another, and like what you're perceiving is like what is happening in the interaction. That's what I think is kind of happening with like these elementary particles, most of them. But they're a little different in which one, causes our perception of a quark is a little different than what causes our perception of an electron. But there would be an explanation as to why you sometimes would see an electron and why you would sometimes see a quark. I know we don't see quarks, but, why you would be able to conceive of quarks within a proton. How about that? But this is what I mean by I think that the bundle idea and of GU is actually the right way to look at this. Whereas like they'll say string theory, it's like strings, it's existence or the universe is made of really, really tiny strings. It's like, it's not even about small and big. You're thinking of the wrong context if you're saying really tiny strings or really, really small dimensions, as I've heard Michio Kaku say. Some of the dimensions must be really, really small. It's like, that's not how dimensions work, dude. Like, what are you talking about? Is length big or small as a dimension? It's like, that doesn't even make sense. But dimensions are not about size. But this idea, I think, makes a lot of sense. Of a bundle. Okay, here. This is like the last thing that I'm going to end on because it's getting kind of late. We'll do actually just two more clips. One, this is like how you need to approach this stuff.
Yeah, let's do that.
Something I endeavor to do with this channel is to understand the theory of someone to the point where recapitulating it back to them is met with agreement, and only then do I think I've apprehended it. And so when you're saying that that should be the first step, I wholeheartedly agree. I hope you felt like I didn't misrepresent GU.
I hope you felt that I didn't misrepresent GU because, to be honest, keeping something alive while wanting to be open to the serious critique, wanting to make sure credit isn't taken away at the same time as not wanting to interfere with the scientific, it's impossible. There's no way of solving this puzzle currently. What's interesting is that we're talking about a group of people who've appointed themselves the border collies of academia. And anytime somebody starts to stray and say, I want to self-publish, I don't really think that this is the correct story, whatever, they slam that person. And that person is pushed back into, well, clearly you're a self-promoter. It's like, really? Have you looked at what your universities put out in terms of PR releases with the lousy research, with the huge claims, et cetera, et cetera? Have you once talked about the problem of the leading people in the field totally misrepresenting things? There are certain tells that they're not even aware of that show you that they're not interested in the underlying subject matter. What they're very interested in is, we've got to make sure nobody arbitrages the flaws in the system. And I'm here to arbitrage the flaws in the system because they are flaws in that system. Now, when it comes to steel manning, that's a really special moment because you get a chance to see whether the person has not only understood something, but added something. And that's one of the things that I got out of your treatment of GU. I think that there are places where you say wrong things, but then you know what? There are places where I say wrong things. And what isn't true is that when you say something wrong, the theory collapses. Or if there's a flaw that you weren't aware of, or there is a flaw that you were aware of, that the theory collapses. This is part of this different academic method, which says the outside world can't tell the difference between a colleague trying to be a colleague and an assassin trying to destroy something or steal it. There's a horrible phrase that I learned in graduate school called gripe and swipe, where the idea is you complain about something and say it's incomplete, it's flawed, it can't work. And the idea is that now you know as much about the theory, and if you can fix the flaws, then it belongs to you. It's one of the reasons
This is something that I think, well, first of all, I will say this. I hope that I'm doing this well with geometric unity in this, because, and I realize I went on a lot of tangents and I don't want to go too late. So I'm actually not going to go too deep into the weeds. Maybe I'll show why I think the 14-dimensional Observerse, I will show that, where I think it comes from. But I also want, before I show that, I want to basically recognize this clip that we just talked about, that I just showed, which is that, and I don't want to misrepresent geometric unity. I do want to add context to what I think are the structures that are being described in it, some of them, because I think that geometric unity is actually largely correct. I think when Eric says we need to quantize, instead of quantizing gravity, we need to geometrize the quantum, essentially. It's like, this is like a flipping of what I think even is like my conceptualization of what the graviton would be. Is like, you're inside the graviton. Like, you're not going to see it inside the universe. It is the universe in a way, if it is anything. Or you could also say the graviton doesn't exist, or you could say we're inside it. And it's up to you what you want to do there. But like, again, because there's always two definitions possible to maintain coherence. I don't know which one is necessary or which one is redundant right now. I need to think about it. But those are really the two options. And or you can say that it exists inside of the universe, but why would you say that? You can't perceive it. And I understand the math supports it, but the math is consistent even if it is the universe. Like, it preserves the symmetry structure of the standard model. And I think that it even makes sense that like the Higgs is not understood what it is. And I think Eric even said that in one of his lectures at UCSD recently. He said the Higgs is an illusion or something, but that really means is like why we see what we saw when we were looking for the Higgs is not understood well, or it's for a different reason than why we see a gluon or a photon. It's like different in some way. Maybe it's not. If it's an illusion, it means it's somewhat more dependent upon like the constraints of our perception that would cause the viewing of this structure and misinterpretation of this structure that we would be perceiving, even though our perception is always going to be relevant to, the perception of any structure, including a photon, and a gluon, but it's just a little different. And so, but I would agree with that. It seems that way to fit my model of things. So I'm trying not that. All that said, like, I'm trying not to misrepresent geometric unity. I'm not taking credit for any of its structures. I'm not trying not to take credit for the Observerse or anything like that. The structure that I'm about to show is not necessarily the Observerse. It's up to Eric on whether or not he says that's the Observerse. And he could say it is. He could say it's not. My only proposal is that this is the context I'm saying is probably responsible for our perception of the Observerse, if it exists, this 14-dimensional two double relational space type of structure. And yeah, so I'm trying not to make assumptions about why Eric thinks certain things or make certain assumptions about what geometric unity is implying. But I am also trying to add context to a model that I think seems to mirror a lot of what I've seen in my own work. And I think that gives it, that's like points. Like so this is not a competitive thing. Again, I think Curt is very, very good at doing this type of thing where before he starts addressing other people's ideas or speaking of another person's work, like he tries to learn it to the point where he could repeat it back to them and explain it back to them, and they would agree that he his explanation or and his description of it is accurate. And I think that that's very important. That's why I'm not claiming that this is the Observerse, but I do think that if it exists, this is why it exists. So with that, let's listen to the clip of him talking about it, and then I will show this structure, and then we will call it.
GU, where you spend most of your time on a 14 manifold rather than on a 4 manifold, where the 14 manifold is constructed from the 4 manifold. You know you're in GU when there are no internal symmetry groups. You know you're in GU when the Higgs field comes out of an add-valued 1-4. You know you're in GU when you begin with a 4 manifold, use it to construct a 14 manifold that behaves like a 3 manifold. You know you're in GU.
That makes sense to me. It seems to make sense to me. I'm not going to say what he's thinking of is exactly what I'm thinking of, but how he described it and those quantities, I will show you. They seem to be relevant.
A moment. So you're referring to Chern-Simons theory?
And
okay. Now, with that, I'm going to delete this because it is not the Observerse necessarily, unless Eric says that it is, because I don't know. But it's a maneuverability matrix. I probably misspelled that, or manifold or something like that. And I'm sure that's probably misspelled. But what is this? This is where I started to see 14 come up a lot in my work. And so if you start to think about in the context of perception, okay, remember that's what is the context of sentient singularity theory. That's the context I'm going to show. So, and again, he might not think this is relevant to the Observerse. I would think that it probably is, even if this is not it. This is a little different, but it's also, I'm just going to show you another place in which this arises. So let's say you have the positive quarks right here and the negative quarks right here, up and down. And this is the first generation of matter in the standard model. An electron, neutrino, an electron, an up quark, and a down quark. That's 4, by the way, interestingly. Then you have charm and strange, and the muon neutrino and a muon. Again, 4. And then you have top and bottom, or truth and beauty, sometimes they're called, and then tau neutrino and tau. Again, 4. That's 3 generations of 4, which is interesting. And then you have us in the universe looking out at the universe. And then you have the universe looking in at us, essentially. This is 1, this is 1, this is 1, this is 1, this is 1. Count 5 plus count 4 plus count 5 is total count 14. And so all of it's 14. You can also look at it like this. These are different symmetrical perspectives to look at this kind of structure, okay? And so one of them is, all at once, that's one symmetry structure. And the other one would be 1, and then 4, and then 4, and then 4, and then 1. And the other one would be 5, and then 4, and then 5. And this is the only ways I've found to do this necessarily that maintain symmetry, and maybe there's more, but I haven't looked at this in a while. But regardless, these are different ways in which you can perceive the symmetry, and all of these sum to 14. Okay, that's interesting. That's all I'm going to say, is that it's interesting. And this is not a physics. I understand this might, people might be like, oh, this is red crayon and crazy person physics. No, it's not. These are the elementary particles in the standard model. These are the fermions. They are the matter particles, the quarks and the leptons, which leptons are electrons and neutrinos. So all the matter, basically, that means like this is all the matter in the universe, and us perceiving all the matter in the universe in our current model, and the universe perceiving all the matter in the universe between us and the universe. And the universe, basically, yeah. So all the matter between us and the universe, which is the outside and inside view. This is the outside looking in, inside looking out. You get 14 every time. Fascinating. Now, this is a little bit more specific. And the observer part of this, somebody said, what is an observer? It's a difficult thing to understand or to define. They said that in the chat, in the live chat so far. So if they're watching this, I hope this is interesting to you. But, and this is also why, like, I wonder why he said Observerse. It's like this, it seems to have to do with observation, but I would need to ask, why did you call it the Observerse? Like, explain, like, really? Because I think it's a great name, actually. If it's similar to this structure, or if it comes from this structure, which I think it does, or even if it is this structure, which only Eric can say. So I'm not taking credit. But this, if every sentient being, this is one sentient being, and this is another sentient being. This is a model, and this, I can't do inside in a two-dimensional format of Excel. So anything that's below is actually inside of the structure above. So this is one mind. Let's say this is a human, and this is another mind within that human. So this would be a cell. Or this could be us, and this could be the mind that is the universe. The being that is the universe that we're within, we are a cell of. And so that's what this is right here. And because of the 4 primary perspectives that I talked about at the beginning, which I think are the reason for the perception of all 4-dimensional manifold structures beyond that, beyond those perspectives, because it is the contextualizing structure of all differentiation, which is a requirement for physics, for perception of any kind of physics. And so, and even beyond physics, like any kind of conception of multiplicity in a relationship is going to be in the context of this. And so you have one 4-dimensional mind, and another four-dimensional mind within that four-dimensional mind. That's what this is. A cell within a human, or you within the universe. Doesn't matter. Same thing. And in every single 4 dimensions, what you really have is like this is why I said it's a degree of freedom or a constraint. It's a perspective or perception of a perspective on a 4-degree, a perspective of a degree of freedom or a constraint. That's what a dimension is. You have 1 positive degree of freedom, 1 negative degree of freedom, 1 subjective constraint, and 1 objective constraint. Let's think about us inside of space-time right now. And so this is us, and we are perceiving this thing, this yellow is us, it's you. And you are going to perceive 4 dimensions of your world. You're going to have 1 positive degree of freedom, 1 negative degree of freedom, 1 subjective constraint, and 1 objective constraint. What is your objective constraint? It's time. Because what's time really? Within your own perception, it's causality beyond you. It's the change that occurs outside of you and that you're subject to. And you're just subject to it. It is your objective constraint. You have no ability to, at least within the length, width, height, and time kind of 4D time, space-time type of model idea without geometric unity, potentially adding 2-time, maneuvering or something in there. Just time is a constraint. You can't change time really, in the fundamental sense, because time, when I say time here, I mean causality. And then you have a subjective constraint, which means the constraint comes from you. An objective constraint comes from the system that you're within and subject to. A subjective constraint comes from you. And so when we're thinking about this in a fundamental sense, it's not length, width, height, and time. It's causality in, beyond you, and then there's like causality within you. What is causality within you? In the context of space, it's you maneuvering between this place and this place and this place and this place in the context of a goal. Okay, it's not just length, width, height, or XYZ without any context. It's within the context of a goal, and it's really forwards and backwards. Okay, so you want to go to Chick-fil-A? You can go forwards towards a new location. It's a positive degree of freedom towards Chick-fil-A. Or you can go backwards towards a previous location that you were in, away from your goal, away from Chick-fil-A. That's what it means, a negative degree of freedom, the ability to go backwards to a place that you've already been. And that you've come from. To go forwards is to go to a place that you had not gotten to yet, to a new moment. And your current your subjective constraint is just your current location always, because you're always in your current location. You can't escape it. It's dictated by you. You are the context of the constraint that confines you to your current location always, because your current location is always your current location. This gets flipped. Okay, so if this is like the structure that is responsible for how we maneuver space-time, which we don't really maneuver space-time up, down, left, and right. We kind of draw it or visualize it that way, but we don't maneuver it that way, which means like that's not really degrees of freedom in how we maneuver. You go from here to over there in space. You don't think about it as I can go and take advantage of length, width, height, and length, width, and height. You just look and you go, I can go from here to there. From a first-hand perspective, space is like 2-dimensional if a dimension is a degree of freedom, as Eric told me all those years ago, and only a degree of freedom. But if it's also a constraint, then you can have a third one there. And so this gets flipped. If this is like space-time, the perception of us perceiving space-time, or you or a cell being inside your body is perceiving your body as space-time, this is what I just call time-space. It's just the opposite. And so the negative degree of freedom of it would be like a past moment, and a positive degree of freedom is a future moment, which really is like causality as a whole almost. It's like as a system. It's like systemic causality. It's not. Whereas this time is systemic causality. This is time as well. It's just this is the system for this being. Okay, so positive degree of freedom, future moment, which is a future state of relationships, essentially due to the interactions that are causal in their impact. And then negative degree of freedom is past moment. And again, this is all within the context of a goal. So this being has a goal and this being has a goal, and they're interacting whether they realize it or not. And the objective constraint of us inside the universe is the causality of the universe, which is time, to how we perceive time. It's change beyond us. What is the objective constraint of the universe? Space. Because it is space from the perspective of this being. It is its own context in that way. And so it's but it's confining of itself. It's constraining of itself, kind of objectively, meaning like the system of its oneness itself is constraining, whereas the system of the oneness of the system is constraining, which is really, this is just our perspective inside the universe, looking at the universe's causal state of being, or which really means like state of symmetry or state of relationship at the current moment, which is due to, though, causality as a whole, which we perceive as causality beyond us. And so then it has, the universe has its own subjective constraint as well, which is it's always in the present moment. Just like you're always in the current location inside of the universe, it's always in the present moment. What a present moment is it's just a collection of a bunch of beings within it being in a certain current location, each and every one of them. Okay? And so what happens is you have this four-dimensional mind, and inside of that you have this four-dimensional mind, and their degrees of freedom and constraints and how they are able to maneuver within the context of each other overlap. This overlap causes, oddly enough, a six-dimensional structure, which I think is why we see the Calabi-Yau manifold at every point in space and time. It's right here. It's why you see this. Who, what, where, when, why, and how. Your limbs you perceive as arms and hands and fingers and legs and feet and toes. And your senses, you have emotion, and which is your sixth sense. By the way, you have six senses, but it's not like, it's just emotion. Emotion is a sixth sense. It's just a feeling. It's a way of perceiving sensory input, or a sensation. So you have emotion and sight, taste and smell, touch and hearing. Color mixing, again, like I said, primary and secondary colors, space-time, past, present, future, length, width, height, from kind of an objective or third-person perspective. But from a first-person perspective, you have like past moment, future moment, and present moment, and new location, current location, previous location, and causality beyond you, and causality within you, essentially. But it's time and space. But this is observable everywhere. I think that, like, if there is a six-dimensional manifold structure at every point in space and time, I mean, like, it just seems to be like it would be a six-dimensional manifold structure at every point of perception, including language, including questions, including regular solids. People say, oh, there's 5 platonic solids, but it's like the sphere is kind of in there as well. Flavors, savory, hot, sweet, sour, salty, bitter. Eric talks about like the tastes sensations as like part of manifold structure sometimes. It's not just a metaphor. I think it is like it is a manifold, and it's probably a Calabi-Yau manifold if you include savory and spicy in there, and not just sweet and sour and salty and bitter. I mean, even the food groups. It's like food groups. Once when I was a biology major, when I started college, because zoology and biology, and particularly herpetology, which is the study of reptiles and amphibians, is like my real main like just passion my entire life. And when I was in I changed my biology major to a finance major because I was so disheartened by the state of the field of biology and zoology. It is just as bad as physics. It is, and but my teacher, my biology professor, had this like phrase where he'd say like, "There's no such thing as a vegetable." He'd be like, "What's a vegetable?" And people would be like, "It's a tomato," and then somebody'd say, "No, that's a fruit." And then somebody else would be like, "No, it's lettuce," and he'd be like, "No, that's a leaf." "No, it's a potato." "No, that's a root." It's like he's changed the context of these things. A vegetable is defined within the context of food, not biology. And so let's think about the context of food. Well, we have the food groups to do that, right? Meat and grains, and dairy and vegetables, and oil and sweets / fruit. It's like this is how we perceive food, is in a 6-dimensional manifold. This is how we taste food, is in a 6-dimensional manifold. This is how we feel food, dry, wet, sticky, slippery, waxy, greasy, in a 6-dimensional manifold. And also here even, this is how we, can also feel like the textures of food or anything else. It's the shapes of food. This is the color of, not color food. This is the color of food. This is how we recreate a picture of food that includes color, either on a screen with red and blue and green, or it printed on paper with magenta and cyan and yellow. It's like this is fascinating, but it's everywhere in our perception around us. What is the context of that? Well, it's this. Okay. And when you go and you start doing what I did earlier, where you're like breaking these down a bit, you're like, this is 4, this is 6, which is the interaction space between two 4D manifolds. So 4 plus 4 plus 6, 14. And when Eric says 2 spaces, it makes me think that what's responsible for at least the conception and perception of those 2 spaces is 2 perceivers, which is one here and one here, 2 4-dimensional perceivers. And so when he says it's constructed from the 4D manifold into a 14-dimensional manifold, though, really, and it's really like 2 spaces, 1, 2, but it behaves like a 3D manifold, which is 1 and 2 and 3. It just seems inevitable that if this is a correct description of what's going on here, which I think it is, that this would be responsible at least for the perception and construction of the structure that would be the 14-dimensional Observerse. It might be the 14-dimensional Observerse. That's up to Eric to state or not, but it certainly would be, if this is correct, then this would be responsible for why the 14D manifold. This is why I think that Eric is onto something. There's lots of reasons why I think Eric is onto something, but his starting with 4 dimensions, which multiplicity starts with 4 primary perspectives, and perception starts with 4 primary perspectives, and multiplicity starts within the conception of multiplicity, and the perception of multiplicity starts with 4 primary perspectives. And that's the realm of physics. Like, that's always the state of physics, whether it's quantum mechanics or general relativity. Or beyond. And if he's talking about a 4D manifold that is constructed from a 14D manifold that is really two spaces. It's constructed of 4D manifold that behaves like a 3D manifold. I mean, what are the odds that this is, if he's right and I'm right, then what are the odds that we're coming up with the same kind of symmetry structure, description, and quantities? Probably 100%. So again, I'm not trying to take credit for anything. I'm not taking credit for the Observerse. And I'm not claiming that this is the Observerse, but I am claiming that if the Observerse is correct, this is why I think the Observerse. All right. I think this is why Eric needs a good experimentalist to work with to help prove his theory. He is. He's working with Brian Keating. Yep, the academic method, 100%. Yep. I think that's one. I agree to the knowledge being applicable thing. I was just getting into an argument with my mother because she was telling me about how this ridiculous concepts about animals being able to talk to humans. You can communicate with animals, but they have a different degree. People wonder where the language comes from and why we can conceive of, abstract structures and then bring them into being. And I've talked about on here, animals use and make tools. All animals use tools. Some animals make tools. Many animals actually make tools. Every time they pick up a stick, they make a tool. Anytime they dig under a rock, they're making a tool. Anytime they just hide behind a tree, they're using a tool. But humans, what makes us different is not tool use or tool building or anything. It's that we make tools to make tools. And this is the first one that we ever did. The knife. It's funny. It didn't start like that, though. It started like this. We would take a rock like this, which is what I did, and you'd hit it with another rock until you got a very sharp shard of it. And this is the first knife. We made a tool for us to make other tools. Us to cut leather and make clothing and cut string to weave. A blade is the first tool to make that is used to make tools. A hammer was probably the first tool that humans made that's handheld, and it's not used to make anything. It's used to destroy things. Initially, there was no nails yet, so like hammers weren't used for construction. They were used for destruction only. Knives, though, were actually the things that were made for construction as well. So it's the tool that initially was made that has allowed for us to make other tools. That is a level of abstraction or of it's a degree of freedom that animals do not have, and it's due to a simultaneous manifestation of many different degrees of freedom and constraints that humans have. Being on land, so that it's not surrounded by water all the time, and so you can make fire. Having walking upright on our feet so that our hands are free, having opposable thumbs so that we can manipulate objects, and having vocal cords so that we can make sounds, and all these things that allow us to then you start building language, and you start taking tools that you've made, and then you use those tools to make other tools, which is the same thing that language is. Language is bird language and animal language is like barking for danger is dogs, and whining for being sad or in pain. That, you can understand your dog, actually. Everything that your dog does, basically, you can understand, other than maybe some scent stuff that you can't smell. But if you understand dog body language and sounds, you understand your dog. They can't speak like us because they don't have all these necessary degrees of freedom and constraints that you need simultaneously to unlock the ability to build things beyond what currently exists with hands, with opposable thumbs that are free and on land, and also, that you can use your voice to communicate and stuff. It's like birds have different calls for all kinds of things. What they don't have is constructive language where certain sounds are built on other sounds, and then you get complex language that can be used to describe things that are beyond the current circumstances. They can use sounds to describe their current circumstances to each other. They cannot use sounds to describe things that are outside of their current circumstances to each other. That is uniquely human. It has nothing to do with IQ. Dolphins do not do this. And they might have they might have a bigger brain than us. I don't know. Maybe not. I have no idea actually. But they're certainly very, very good at some things and much better at some of things than we are. But that doesn't matter. Like, they don't have the ability to abstract. The dolphin is not thinking about what it's going to want to eat tomorrow. It only thinks about what it might want to eat now. No matter how smart it is, in that way, it's closer to like a fly than it is to us, which is weird. Doesn't mean they're not more, intelligent than a fly. It just means like they can't conceive of situations beyond their current circumstances. That just means they can understand their current circumstances better than a fly, but they can't conceive of situations beyond their current circumstances like we can. So Dr. Dolittle is nonsense. And you already can talk to your dog. But, all right. Yeah, I didn't like this guy, especially when he went on Joe Rogan and was making fun of Terrence Howard. Who was doing that? I didn't know. I don't think Eric did that. This guy doesn't know what he's talking about. To be honest, I'm sorry I have to say it. I don't know if you're talking about me or not. It is interesting and I'm listening. Good. Hello. Dolphins are way closer to us than a fly cognitively. Do you know that? Like, what does it mean to be closer to us? I don't think that I think you need to think about what it means for us to be closer to us cognitively. Like, their constraints and a fly's constraints and degrees of freedom in its ability to conceive of circumstances is more limited to here's the thing. In the context of our current circumstances, if a dolphin's thinking about its current circumstances and we are thinking about our current circumstances, we're closer to a dolphin. But in our ability to conceive of circumstances beyond us, and a dolphin's lack of ability to do so, probably, it's much more similar to a fly. So it just depends on the context. If you're talking about just conceiving of your current circumstances, yes, the dolphin's closer to us, probably. But if you're talking about the ability to perceive circumstances beyond us, they're probably just as limited as fly. They're not like us. It's different. You cannot think about what it would be like to construct an airplane or what it would even be like to fly, like without, like if you can't ever leave the ground, I don't know. Dolphins probably can think about what it's like to fly because they can jump out of the water and see birds and stuff, probably. But like, they're not going to think about what it's like to build a plane. They're just going to think about what it's like to soar for a minute. And obviously making assumptions, but as somebody who thinks animals are emotionally much more similar to us, I actually think all animals are basically the same emotionally, including humans. Like, people that say like reptile brain, they're just instincts, action, reaction. That's not true at all. They display affection to each other. They have preferences for their friends, and they have romantic partners essentially, or like mates, who they like and who they don't. There are individuals who they like, individuals who they don't. There are snakes that will live under the same rock with a mouse, and they will go out and eat the other mice and then come back and live with this mouse. And they are friends, basically. Like, what do you call somebody who you hang out with? Or they're at least roommates, It's like they're much more sophisticated emotionally, or at least they're much more similar to us emotionally, I will say. I don't even want to say sophisticated because I don't like the term complexity or sophistication, because what is sophisticated and what is complex? I don't know. But they're much more similar to us emotionally than most people think. But their ability to think about circumstances beyond their current circumstances is practically non-existent. That doesn't, and I know that like animals plan, like dolphins plan, but so do flies. If you go to swat a fly and it doesn't run right into your hand and it's instead goes this way, it is looking at the current circumstances and thinking ahead and being like, I need to go that way. And if a rabbit is running down, a path and wolves are like, I'm going to go cut it off this way. And, you guys come this way. They are thinking ahead, but those thoughts are still contextualized by their current circumstances. They're not thinking about what they're going to hunt for tomorrow. They're not. That's what we do. It's not helpful to them to be able to do that. They wouldn't be able to do anything about it. So if you can't make tools to make tools, there's no point in being able to conceive of circumstances beyond your current circumstances. And we're not even, if you have the right constraints and degrees of freedom, then you aren't even conceiving of circumstances beyond your current circumstances, because your ability to make a tool to make tools is within your current circumstances. I've told this story on here many times before. Is my mentor in zoology and ecology. He said to me that when he was in high school, the greatest teacher he ever had was his shop class teacher. And he had everybody write in high school, and he had everybody write down what they wanted to build for the semester. And then as soon as everybody wrote it down, he said, okay, now we're going to build the tools to build the thing that you want to build. And I wasn't even in that class, but hearing that story, I internalized it. I'll never forget it. That's the difference between humans and any other animal that exists, or being that is below us, at least. If a technological sentience arises, it would have additional degrees of freedom. And, God and the universe, those sentient beings have additional degrees of freedom. But anything below us, like cells and animals, even which are not below us in the same way, which I guess I'll show this. Just because Eric, I know we're just talking at this point, but Eric's mentor, one of his mentors was Raoul Bott, I think, was like his unofficial advisor. And I believe that this is my theory, is that this is the manifestation of Bott periodicity, or it's a manifestation of Bott periodicity in the world, which is a series of loop spaces, loops within loops, essentially. What is a loop? It's a self-referential string of information. And so what is that? It's like, what is something that's self-referential entirely? It's a self-aware being. So I think that this is kind of the fundamental assembly structure of sentience. And it doesn't start at quarks. Quarks are not sentient in sentient singularity theory. It starts at hadrons. That's the first. A proton and a neutron are the first instantiation of like male and female in life. Like they are sentient in my proposal. And you can't say that that's crazy, because you can never know whether or not another being is sentient from the outside. So you have no evidence that they're not sentient. In fact, I believe that I have evidence that they are, but it's just evidence. It's not proof, because you can never prove it from the outside. Only you are constantly aware of your own sentience, but nobody outside you is aware of your sentience. They just assume your sentience. So I'm assuming the sentience of protons and neutrons, and that is the initiality of gender as well. And then you have atoms, which are assembly of hadrons, molecules, which are assemblies of atoms, cells, which are assemblies of molecules, organisms are assemblies of cells, a family is an assembly of organisms, a caste, or kind of like a tribe. We don't have the right word for this yet, but it's an assembly of families, and a technological singularity is an assembly of castes or tribes. Maybe kides, I should call it, or something. It's like your role in society and your family lineage, essentially. Almost like ethnicity, but not. And so this is 8. And this is just my theory, and I've talked about this many times on here. I think that this would follow Bott periodicity. Might not be the only instance of it, but I think it is an instance of it. and I've talked about it on here before, where I was talking to a math PhD, and he was like, Tyler, I don't think that you understand Bott periodicity. And I was like, okay. He was like, I want to explain it to you. I want to help you. And I was like, okay. It was in this Discord that was kind of a hostile place for me sometimes. And I was like, okay, let's he was like, I'll explain it to you in a room on Discord or whatever, like in a channel, in a voice chat. And so we went in there, and everybody started coming in to watch, because every time I showed up, it was just like a spectacle. And he was like, it's not what you're saying it is. It's a series of loop spaces. And I was like, yeah, I know. I'm saying that this is a series, the structure, the metaphysical structure, that structural outline of this generative nested structure of sentience that I'm proposing is following of Bott periodicity. And he was like, it's not though. It's a series of loops within loops and things like that. And I'm like, yes, you're describing the structure, I know, but like that, where is it? Where is Bott periodicity? Why is Bott periodicity? Like, it's not just an abstract idea, I don't think. I actually think it's something fundamental and like an incredible, like if it is this, like that makes it so much more than whatever it is currently assumed to be alone. It's not, to say something's a series of loop spaces is a description that we already have. So why are you repeating it? But somebody chimes in there like, okay, what's clear? Tyler might be wrong, but he might be right, but he also might be wrong. But what is clear is that, this other guy who's the math PhD doesn't really know either what Bott periodicity is. Maybe Tyler knows, maybe Tyler doesn't, but so-and-so does not really know what it is. And because you can't just say, I know what it is, because it's a series of loop spaces. Where is it? Like, you don't, it's like that Scott Aronson talk that I went to recently at, that was put on by Ekkolapto, which is, I recommend subscribing to on YouTube, and you can see that lecture. I'm in there and I asked some questions. But he was asking, what does it mean to know a number? Like, to know of a number. And like, he was like, this is the highest prime number that we know. And he wrote it on the board in scientific notation. He looked it up and then he wrote it. He's like, this is the highest prime number we currently know. And he's like, but I'm going to tell you that I know the next highest one, actually, one that's even higher, whichever one is after that, that's prime. And he's like, why doesn't that count as knowing the number? Basically, we kind of agreed that your goal matters. You can't just say to know a number. So the same thing goes with like, to know what Bott periodicity is. What does that mean? Well, you need to contextualize it. Where does it manifest in the world, in the physical world, or even the mental world, which in this case, it's like in the world of nested sentient beings. So like, it's both. In the non-mathematical world, in the observable world, I guess you could say, and the world of observers, then that's what I'm proposing is Bott periodicity, I think. And it's not just because it's 8. There's multiple little reasons why I think it might be the case, but I'm not a mathematician. And I don't even know if that's enough qualification to be able to prove it or not. But it's probably a component. This is what I mean by like, we need to, it's tough to make progress when we don't even know what it means to know something anymore. Because we lack the context of knowledge. So with that, I will say, I really appreciate Eric going on Curt's podcast. I really appreciate Curt making the effort that he's made to understand geometric unity in an honest way that is much more rigorous than anyone else that I've seen so far. And I appreciate that conversation happened and it was made public. If I misrepresented any of Eric's ideas, I invite him to let me know. Anyone, as I've said, who I talk about, whose work on here I talk about, they're always welcome. And if you guys liked it, please hit the like button. If you hated it, please comment in the comment section why, and I will probably read your comment and give my response on a future AMA. So with that, thank you, everybody. Peace, and till next time.